Hello my dear friends, I welcome back you to my YouTube channel, that is Beginners Chemistry, where you can learn the chemistry in easy manner. In our last class already we have studied about the which one classification of the organic compound. In that classification of the organic compounds we have seen what we have seen. One is a closed chain, one is a open chain. In that closed chain we have seen the aliphatic, clear, and in that aliphatic we have seen the saturated one and the unsaturated one. When it comes to the which one, when it comes to the closed chain we have seen the homocyclic and the heterocyclic. In that homocyclic we have seen the which one, alicyclic, and the next one we have seen the aromatic. Then after that we have seen the heterocyclic, right? Clear. Now in the then followed by the we have seen the which one, functional group. Now in this lecture we are going to start the which one, we are going to start the IUPAC. Clear. Now IUPAC, now with the starting of the IUPAC with the alkane and alkane, then after that the followed by the functional group and disubstituted, and if suppose two or more functional groups if they have given, or if suppose two or more single bond or two or more which one, double bond or triple bonds have given, how to write the IUPAC in this lecture we are going to see. Now let's start our lecture. Now, before going to start the IUPAC, I just want to give you a brief introduction of the functional group that already we have studied in our last class. But once again, I just want to give you the brief introduction. My dear friends, if you remember these functional groups, now aldehyde C double bond OH, ketone C double bond O bond, clear, and carboxylic acid C double bond O bond H. See, remembering of the functional group will play very important role in our organic chemistry. Many of the students, they will face very much difficulty where they don't know what is the functional group, aldehyde functional group, they don't know what is the ketone functional group, they don't know what is the carboxylic functional group. My dear friends, try to remember. Clear. Now remembering is a very difficult thing as the students we and the faculty we used to do, but just daily once if you revise, that functional groups will be in your mind. Clear. Now once again I just want to give you, already I explained you, this alkane will not act as a functional group but it is in the form of the organic compound, just they have introduced. Clear. Next, alkene. Now this is the alkene, means carbon double bond carbon is the alkene. Now this alkene, carbon double bond, clear, one single bond and one double bond it is there, right? Clear. Now this we call it as a which one, alkene, and this will act as a, it will not act as a main functional group. Main functional group it will not act. Clear. Next one will be the triple bond. Triple bond also will act as a which one, functional group only. Now triple bond means one sigma bond and two pi bonds. Clear. Next one will be the amine. Amine is a one type of the functional group. Now here this R indicates that this is alkali. This R indicates that alkali. What is the alkali, sir? I will now the next we are going to start there. I will explain very clearly. Then next one is the thiol. Thiol is a functional group. That thiol means you have to consider that is SH. Now amine means you have to consider it as a NH2. NH2. Clear. Now alcohol means you have to consider it as a OH. Clear. Next, thioketone. Thioketone means carbon double bond S. Clear. Next one we are having the ketone, means C double bond O. You have to consider it as a C double bond O. Next we are having the aldehyde. Aldehyde means you have to consider that C double bond O H. Next one will be the cyanide. Cyanide means C triple bond N. C triple bond N. Next we are having the amide. C double bond O NH2 is amide. Clear. Now my dear friends, you can see C double bond O NH2 is amide. Now here carbon attached with NH2 is amine. Clear. In that amine we are having the 1 degree amine, 2 degree amine and the 3 degree amine. Already in the degree of amines, degree of alcohol, degree of carbon, degree of hydrogen, all in that lecture already I explained you very clearly about this amine. Done. Next one, acyl halide or acid halide we can say. Clear. Now this is C double bond O X. Next one will be the ester. Ester means C double bond O R. Clear? Now next one will be the acid anhydride. Acid anhydride means C double bond bond C double bond O R. Clear? Next one will be the sulfonic acid. Sulfonic acid means SO3H. Now this sulfonic acid structure will be now sulfur double bond bond OH. Clear? Now this is the structure of the sulfonic acid. Clear? Next one will be the carboxylic acid. C double bond OH. C double bond OH. Clear? Next, this halogens already I explained you in the last lecture. Halogens, nitro, alkali, phenyl, ethers will not act as a functional group. Blindly believe this one. This is a very important key point you have to remember. Clear? These halogens, nitro group, alkali, phenyl and the ethers will never and ever will act as a active functional group. Clear? They will always act as a substituents. Sir, what is the meaning of the substituents? Now, with the IUPAC, when we start the IUPAC, there I will explain very clearly. Done? Clear? Now, start with the IUPAC. Now, why we are going to study the IUPAC and what is the role of the IUPAC and what is the full form of the IUPAC? Full form of the IUPAC already you know, that is a International Union of Pure and Applied Chemistry. Sir, why we have to study the organic compounds of IUPAC? Because before the IUPAC, different scientists has given the different names for the organic compound. So remembering of the one scientist is saying the one different name for that IUPAC and or compound. Now one scientist is saying the different name to the which one for the same compound. So remembering of the which one for one compound, remembering of the two or different names is a difficulty. So that's the reason all the chemists and they have given the one pure form of the naming to that organic compound to easy to spell that compound or easy to say that compound. Clear? To not to get any difficulty while we are studying about that compound. That is known as the IUPAC, International Union of Pure and Applied Chemistry. Clear? Now, first of all, to name the IUPAC of the any of the compound, to name any IUPAC naming of any organic compound, this formula what I was giving, if you remember what the formula I was given, based on that only we can name to the any of the organic compound very easily. First you see, first one is a 2 degree prefix. First one is a 2 degree prefix plus 1 degree prefix. Next one will be the 1 degree prefix plus root word. Clear? Plus 1 degree suffix. Clear? Plus 2 degree suffix. Plus 2 degree suffix. Clear? Remember the IUPAC formula in this manner. 2 degree prefix, sir. What is the 2 degree prefix? 1 degree prefix. What is the root word? 1 degree suffix and a 2 degree suffix. Now I will explain. So for the any of the organic compound to name, some organic compounds it is having the branching, some organic compounds it is having the functional group, some organic compounds it is having the cyclic ring. Clear? Some organic compound may be the alkane, some compound may be the alkene or the alkane. So to clear, if suppose all are mixed in that compound, to clear and to justify that compound name, so we have to follow this sequence. Which one? First is a 2 degree prefix. What this 2 degree prefix will say? 2 degree prefix will say, what did 2 degree prefix will say? It says about substituents, substitution or substituent, or branching present in organic compound. Whatever the substituents are branching that are present in the organic compound. Already I explained you very clearly which are the substituents or which will act as a branching. That is alkali and halogens and NO2 and NO2 etc. These will never and ever will act as a functional group. These will act as only which one? This will act as only the substituents. Next comes to the 1 degree prefix. What is the 1 degree prefix say? 1 degree prefix says if in that organic compound any cyclic ring, if it is there, cyclic ring or bicyclo or spiro compounds. Clear? Now this will be said by the which one? 1 degree prefix. Next one we are having the root word. Root word means if in the organic compound, if we are having only one carbon, one carbon means meth. Okay, about this root word I will explain here very clearly. Now listen. First of all, root word. What is the meaning of the root word? Root word, if in the organic compound, if you are having only one carbon, then we can say this at that one carbon we can say it as a meth. If the two carbons we are having, that we can say it as a eth. If the three carbons we are having, we can say it as a prop. If the four carbons we are having, then we can say it as a but. If the 5 carbons we are having, then we can say it as a pent. Clear? If the 6 carbons we are having, then we can say it as a eggs. Now 7 carbon we are having, then we can say it as a yept. And 8 carbons if we are having, then we can say it as a opt. 9 carbons we are having, then we can say it as a non. Clear? Now 10 carbons we are having, then we can say it as a dec. Clear? Now 11 undec. Now 12 dodec and etc. Clear? Now comes to the 1 degree suffix. What the 1 degree suffix says? 1 degree suffix says, here this 1 degree suffix is saying about which one? If in the organic compound, if it is a single bond, completely if it is having only single bond, there is no any double bond, there is no any triple bond, then we can say it as a completely, if the organic compound is completely single bond, then 1 degree suffix we can say it as a ane. Clear? Now if suppose any double bond if it is present, then for that one we can say it as a ene. Clear? If any triple bond if it is present, then we can say it as a ine. Clear? Now 2 degree suffix. Now what the 2 degree suffix will say? Blindly believe that this 2 degree suffix will say about the functional group. If any functional group is present in that compound, that functional group will be said by the which one? 2 degree suffix. Clear? Now this you have to remember. 2 degree prefix plus 1 degree prefix plus root word plus 1 degree suffix plus which one? 2 degree suffix. This is the formula you have to remember. Done. Now this is about the IUPAC. Now we are going to see the common names. Now what is the common names? Clear? Now to write the IUPAC names, sometimes 2 or more substituents will be present. If the 2 or more substituents if it is present, how to name that substituents in the IUPAC? To understand for that one, these common names will play very crucial role. Clear? In these common names, first already when we are studying the functional groups in the starting, we have seen the R, right? R. So what is the meaning of the R? Already I explained. See, if one R and H if they have given, if the R and the H if they have given, this H if it is R and F if they have given, this is a alkane. It is represent to the alkane because this is a carbon and a single bond. From this is alkane. From this alkane, if the hydrogen is lost, then it will be defined as a alkyl. We can name this as a which one? Alkyl. Clear? Now just a general example for you. This is CH3H. One carbon and 4 sigma bonds. This one we say it as a methane, right? Methane. Clear? Why this is a methane? Sir, how you are saying this as a methane? Now what is the IUPAC formula? 2 degree prefix plus 1 degree prefix plus root word plus 1 degree suffix plus 2 degree suffix. Clear? Now here the compound they have given it as a CH4. Now are you seeing any substituents in this CH4? No. Are you seeing any cyclic compound in the CH4? No. Clear? Root word 1 carbon, it is a meth, right? Meth. Clear? Plus. Then here all are the single bonds in the CH4. Single bonds in the CH4. Clear? All are the single bonds means that should be the ane. That should be the ane. There is no any functional group. So this one will be the name will be the methane. CH4. Now IUPAC name will be the methane. Clear? This is a CH4, right? Now from this CH4, if I was remove the one nitrogen, then it will become CH3. This one we say it as a methyl. This one we say it as a methyl. Clear? Next one. C2H6. This one we say it as a ethane. Ethane, because 2 carbons eth and all are the single bonds N. Ethane. Now if you remove the one nitrogen, it will become C2H5. This one we say it as a ethyl. This one we say it as a ethyl. Clear? Now same thing. C3H8. If you remove one nitrogen, it will be C3H7. This one will become propyl. This one will become propyl. Clear? In this manner, common names for this one R and H. If it is there, this we can say it as a alkane. If you remove one nitrogen from this alkane, that will become alkyne. In this manner, it will become. The namings of that one will be the methyl, ethyl, propyl. Methyl, ethyl and propyl. Suppose this only, if it is attached to the compounds, then how we can naming for that compound? This one is a compound and the name. If suppose same alkali, that alkali if it is attached to the different functional group or different compounds, then how we can naming for that one? See, first one, this is R, and if it is attached to the OH, if it is attached to the alcohol functional group, then we can say this as a which one? Alkali alcohol. Alkali alcohol. Clear? Then if it is attached to the halogen, then we can say this as a alkali halide. Alkali halide. Clear? Example for this one, if suppose R and Cl it is attached. Halogen is Cl, bromine and iodine, right? Clear? If the R and Cl is there, then we can say this as a alkali halide, means this is chlorine, right? We can say it as a alkali chloride. Alkali chloride. Done? Clear? If suppose here in the place of this R, in this place of this R, either it may be the CH3, either it may be the C2H5, either it may be the C3H7, etc. Suppose this CH3 and the chlorine if it is attached, CH3 and Cl if it is attached, then the name of this one alkali, right? This is alkali. What? Which alkali? This is methyl. This is methyl, right? Methyl, and this is a chloride, right? The name of this one will become methyl chloride. Name of this one will become methyl chloride. Clear? Now next, if suppose R and SH if they have given, then we can say this as a alkali thio alcohol. Alkali thio alcohol. Clear? If suppose NH2 if they have given, then this one will be the alkali amine. Clear? If suppose ROR if they have given, this is dialkyl ether. Dialkyl ether. Clear? Next, RSR if they have given, this is dialkyl thioether. Dialkyl thioether. Clear? Next, R double bond O, R C double bond O, R if they have given, this is dialkyl ketone. Dialkyl ketone. Clear? If suppose if they have given RNHR, this is dialkyl amine. Dialkyl amine. Clear? Now if suppose RNRR, if suppose if they have given, name of this one will be the trialkyl amine. Trialkyl amine. Next, R dash. R dash means if it is here the Here it is CH3, here O, and R dash means other than CH3. Here R dash means other than CH3. So I was taking this as a C2H5. C2H5. Then the name of this one will be the alkali, which one? Alkali or ethyl methyl ether, or this one we can say it as a, which one? Ethyl methyl ether, like that. Alkali ether, alkali ether. Clear? Next one, R C double bond O R dash. Clear? Now this one will be the alkali ketone. Clear? Done. In this manner you have to remember the names if R is attached to the any of the functional group. Clear? Now next we are going to see the another different types of the common names. First we are going to study here about the group. What is the meaning of the group? Group is nothing but atom or a group of atom which possess free valency. What is the meaning of the free valency? Now listen. Free valency are called group. None of this remembering of this common names which I was going to explain, many of the students they will make the mistake in these common names itself. They will make very much difficulty to identify these groups. Here we are going to study the iso. The name we are going to say the iso. We are going to say here the tertiary. Here we are going to say the neo. Here we are going to say the n. So identifying of these common names, if you identify these common names, half of your chemistry will become easy for you. Identifying of the molecule also will become easy for you. Now how to identify the groups? Now how to remember that groups? I will explain very clearly. Now you just listen carefully. Clear? Now if there are two or more structures of the same molecular formula. Now why we are saying this as a group are the atoms. Now free valency are called as a groups. Now if suppose two or more molecular formula if it is having, if the same compound, if two or more same molecular formulas if they are having, then we use prefix as n, comma, iso or neo or tertiary. Clear? So how to use n, iso, neo and the tertiary? Now we'll see. First normal groups. Normal group means n. So here we are giving it as a n. Naming of that compound we are giving it as a n. So which one we can give it as a n? For which compounds we can give it as a n? For first one, this groups having no branching. There is no branching in that organic compound or straight chain. Groups having no branching or straight chain. Clear? For that type of the compounds we will give it as a n. Means free bond valency. Free valency I said, right? That is only the free valency is nothing but free bond. Free bond will come either first carbon or last carbon Clear? Now you see, example I will take it as a CH3 CH2 CH3. Name of this compound is propane, because 3 carbons we are having, all are single bonds, so this is propane. What I said, free bond or free valency it should be there. So I will remove either one hydrogen from this carbon or hydrogen from this carbon. I can remove it from the first carbon or I can remove it from the third carbon. If I remove the hydrogen from the third carbon, then the compound will become CH3, CH2 and CH2 and free bond. This is a free bond. Then here the free bond is present here, right? Free bond is present here. Then what is the name of this compound? Already I explained it. From the alkane, if you remove one hydrogen, it will become alkyl. It will become alkyl. So here from the propane, I was removed one hydrogen. Then the name of this compound will become N-propyl. It will become N-propyl. Clear? Because it is a straight chain. Because it is a straight chain. Now, if you see, then if suppose if they have given CH3, CH2, CH2, CH3. Clear? Name of this compound is butane. This is butane. If you remove the one hydrogen, if you make one free valency at the last carbon, if you make the free valency at the last carbon, then the name of this compound will become N-butyl. Name of this compound will become N-butyl. Clear? Done? Now, next we are going to see word of iso. Then for which compound? See, many of the students, they will get difficulty to identify the iso groups. So I will make you very clear and I will make you very simple to identify you the iso groups. So many of the students, they will get confusion over the identifying of the iso groups. Iso groups. So what are the iso groups? So when a methyl group is attached, to second last carbon of straight chain, carbon with one hydrogen, those groups are known as the iso groups. Now you see here one CH3, CH2, CH3. Clear? Now this is a propane. If I remove the hydrogen from this last carbon, 1, 2, 3. If I remove the hydrogen from the which one? Last carbon. Then it will become CH3, CH2, CH2 and free valency. This one we call it as a N-propyl. Okay. Now what I was doing, I was removing the hydrogen from this second carbon. Now I was removing the hydrogen from second carbon. Clear? If I remove the hydrogen from the second carbon, now the compound will become CH3, CH, and here it will be the free valency, and here it will be the CH3, and here it will be the CH3. Clear? Done? Now this is a isopropyl. This one we call it as a isopropyl. This one will be the isopropyl. Now in this straight chain, this is a numbering. If you give it from here 1, 2, 3, either you can give the numbering from here also 1, 2, 3, 1, 2, 3. What I said, when a methyl group is attached to the last second carbon of the straight chain, right? Now if you consider this as a straight chain, in this manner, if you consider it as a straight chain, last second carbon, this is a last carbon, right? Or last second carbon, this is third carbon. Now this is the last second carbon with the which one? Methyl and one hydrogen, and the free valency it is there. Here are last second carbon should be have the methyl and one hydrogen. This type of the groups we call it as a which one? Iso. Which one? Iso. This compound name we call it as a iso. And this one, what I said, from the alkane, if you remove one hydrogen, it will become propyl, right? This one will become isopropyl. Done? Now next example. Now here CH3, CH2, CH2, CH3. This one will be the butane, right? Butane. From this butane, if you remove hydrogens from any of the last carbon, it will become N-butyl. How it will become? CH3, CH2, CH2, and it will become CH2 bond. CH2 bond. So how to write the N-butyl now? N-butyl. Now what I said, to make it as a iso, if you remove the hydrogens from the last carbons, it will become N. It will become N. If you remove the hydrogens from the internal means inside. These are the terminal. Last carbons are terminal and the remaining carbons are internal. If you remove the hydrogen or if you make the free valency in the internal carbon, then it will become iso. What it will become? It will become iso. Now you see, here it will become CH3, here CH, here it will be the CH. Now what I was making here, for this carbon I was making the free valency. For this carbon I was making the free valency. Here the one CH, CH3, and it will become the CH2 bond. CH2 bond. Clear? Done? Now what I did here, this is a CH3. This is one free valency I made. One free valency. See, this is the same molecular formula. It is having the different structure, right? Clear? Now for this one, if you give the naming for this one, 1, 2, 3. 1, 2, 3. Last second carbon should have the methyl group and one hydrogen. If this type of the structure, if you have seen, that structure we call it as a iso. And how many carbons are there? 1, 2, 3, 4. Total 4 carbons. From the butane, if you remove one hydrogen or if you make the one free valency, then we can say this as a isobutyl, right? Isobutyl. Is it clear? Done? Now next one, another type we'll see. CH3, CH2, 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 CH3. This is a pentane. Either any of the last carbons, if you make it as, this will become N-pentyl. Now I want to make it as a iso. For this only, same this pentane, same molecular formula, but different in structure. How? I can write this one in this manner, right? CH3, CH2, CH2. Clear? No, sorry. Now CH3. Now this is CH2 and this one will be the CH3. Clear? Now you see, same molecular formula. C5. How many hydrogen? 3, 2, 5, 7, 9. 9 plus 3, 12. H12. Now you can see here also 1, 2, 3, 4. 4 carbons and here 5 carbon. And hydrogens 3 plus 3, 6, 7, 9, 12. This is also C5H12. But this name is pentane. And if you remove the hydrogens from the last end, it will become pentyl. But for this molecular formula, how to give the naming for this one? Now, if I make the free valency of any of the last carbon, for this one, for the straight chain, if you remove the hydrogens, for that one we are giving the N. For this one, it has exist in the some other structural, right? Some other formula it is existing. Same molecular formula but different in structure. When it has existed in the different in structure, and if you remove the, or if you make the free valency of the any of the carbon from, if you make the free valency from this carbon, now you see CH3, here CH, here the CH3, here the CH2, and here the CH2 bond. Clear? Now what I said, last second carbon of the straight chain. For this straight chain, this is the last second carbon, right? For this last second carbon, methyl group is there, one hydrogen it is there. Methyl group and the one hydrogen it is there. For that one, for this type of the groups, we call it as a which one? Iso. This one will be the iso. Then how many carbons are there? Total 5. And one carbon has been become free valency here, right? So this one will become isopentyl. In this manner, we have to identify the which groups? Iso groups. Clear? Next one. Next type of the groups we are having that is neo. Third type of the groups we are having neo groups. So for which groups or which compounds we can say it as a neo? Neo means when two methyl groups are attached, when two methyl groups are attached to last second carbon, for the last second carbon, two methyl groups of straight chain, of the straight chain carbon, of straight chain, two methyl groups are attached to the last second carbon of the straight chain. Clear? Those groups we call it as a neo groups. Done? Now you see here, 1 carbon, 2 carbon, 3 carbon, 4 carbon, 1 carbon, 2 carbon, 3 carbon, 4 carbon and 5 carbon. This we say it as a which one? This we say it as a which one? Pentane. If you remove any of the hydrogen from here, this one it will become CH3. This one will become N-pentyl. This one will become N-pentyl. Same this pentane, it will be exist in the different isomer, right? The same pentane, it will be exist in the different isomer. Now that it will be exist in the CH3, CH2, CH3. This is CH2, CH3. Now this one we can say it as a isopentane. This one we can say it as a isopentane. If you make it as a free valency here, then we can say this as a isopentyl. Clear? Now the same pentane, it will be exist in the another different isomer. How it will exist in the other different isomer? That will be CH3, CCH3, CCH3, now CCH3. Clear? Now this one we say it as a neopentane. Already I explained you. If you consider this as a straight chain, last second carbon should have the two methyl groups, right? Two methyl groups. And if you make it as a free valency for here, if you make the free valency here, then it will become what? Neopentyl. It will become neopentyl. Clear? In this manner, neo groups will come. Done? In this manner, we have seen the which one? N. For if you consider for the pentane, example of the pentane, this is C5H12. This is CH3, CH2, 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 CH2 bond. Or this is free valency. Then this one we can say it as a N-pentyl. Now here the CH3, here the CH, here the CH3, here the CH2, and here it is a CH2 and it is a free valency. Now last second carbon, already I explained you very clearly. Last second carbon, methyl group with hydrogen, this one will become isopentyl. Next CH3, CH3. Now it is a CH3. Now here one free valency it is there. This one we say it as a neopentyl. In this manner, N, iso and neo. Clear? This is the alkane. This alkane will exist in the three different isomers. When it has existed in the three different isomers, means three different forms when it has existed. Why it is existing in the three different forms? Because already I explained in the starting class. Single bond single, carbon and the carbon, it can rotate very free easily. When it can rotate very free easily, catenation property, when it is having the catenation property, either it may exist in the branching, either it may exist in the ring, either it may exist in the straight chain. Already explained. So that's the reason only now it is existing in the different isomers. When it is existing in the different isomers, for that one, first straight chain one, if you remove one hydrogen from the last, so we are saying it as a N. Then when it has existed in the another structural isomer, when it has existed in the one isomer, if you make it as a, or if you make it as a free valency from the last carbon, now in that straight chain last second carbon, hydrogen and the methyl group, it is, if they have given, for that one common name we are giving it as a iso. Then same pentane again it will be existed in the another type of the isomer. For that straight chain, if you last second carbon, if it is having the two methyl groups, then that common name we will get as a neo. You can give it as a neo. Clear, right? Done. Next one. Next, another type of the common names we are having. Another type of the common names also we are having. What is the another type of the common names we are having? That it is very important, that we can say it as a amyl. Amyl compounds. Amyl compounds are optically active compounds. Are optically active. So what is the meaning of the amyl or optically active? See, to show the optically active or amyl, what it should have, means here this is very important. Now when it start the isomer chapter, there I will explain very clearly, but up to now you just remember what is the meaning of active or optically active. Optically active, amyl, and for some compounds we have to say it as a optically active amyl. Amyl or optically active amyl. For that one, see, if carbon is attached with, if the carbon is attached with four different groups, then we can say it as optically active. We can say it as a optically active. And we can say it as a optically active. Sir, what are the four different things? This carbon, if it is attached with the some X, here it is attached with the Y, here it is attached with the Z, here it is attached with the A. So these four are different, right? These four are different. So this carbon is called as a optically active carbon. Optically active carbon. Or chiral carbon we can say. This is not the chiral, this is chiral carbon. Clear? Optically active or the chiral carbon. Clear? Now another definition or another definition for this amyl compounds, we can say it as a, it can be represented by carbon attached with four different groups or same groups, but it should have 5 carbons in compound. 5 carbons in compound. Then we can say amyl. Then we can say it as a amyl compound. Or then we can say it as a amyl. Clear? Now you see. Here this is a one CH3 I have given here. One CH2. One carbon. Here the one hydrogen. Here the one is CH3. Clear? Now here it is a CH2 and here it is a one free valency. Either here the free valency, any of the group it may attach. Now you see this carbon, here we are having the CH2. Here we are having the CH3. Here we are having the hydrogen. Here we are having the ethyl, right? C2H5. This is C2H5. So 4 different groups are attached. To this carbon, right? Now what it should have? 5 carbons in the compound. If it is having, then only we can say it as a amine. Done. Then we can say this as a active amyl. If this type of the substituent if you see, then we can say this as a active amyl. Clear? Next one. Next another compound CH3, CH2, CH, and here it is a free valency, and here it is a CH2, and here it is a CH3, and it is a CH3. Now here we cannot say now this as a active. Why? Here you can see CH3 CH2, here also CH3 CH2, both sides same groups are there, so then we cannot say it as a active amine, then only we can say this as a secondary amine, then we can say this as a secondary amine. Okay, now next, if suppose CH3 CH2 CH2 CH, and here it is a free valency, and here it is having the CH3 now. Now here suppose here any group it is attached, let's suppose here the group attached, here it is some A group it is attached. Now you see this carbon is now active. Why this carbon is active now? Here one group's methyl, here one group is hydrogen, and one group is propyl right now. This is C3H7, C3H7 propyl. So propyl is different, methyl is different, A is different, and hydrogen is different. So four different groups are attached to the carbon, right? Then we can say this as a which one? Secondary amyl. This one we can say it as a secondary amyl. Secondary amyl. Which one? Active secondary amyl. Then we can say this as a active secondary amyl. Clear? Next. Next we are going to see the secondary groups. Next we are going to see the secondary groups. What is the meaning of the secondary groups? Now carbon having free valency, carbon having free valency attached to two carbons, carbon having free valency attached to two carbons, that is CH3 CH, CH2 CH3. Now here it is having the free valency, here this carbon having the free valency, right? Here this is having the free valency, and it is attached to the two carbons. Then we can say this as a secondary. And how many carbons we are having? 4 carbons we are having, and one hydrogen is left to, or one hydrogen is less to the butane, right? So we can say this as a secondary butyl. Secondary butyl. Done? Clear? Now next CH3, here it is a CH and the free valency CH2 CH2 CH3. If suppose if they have given this is secondary pentyl, this is secondary pentyl. Clear? Next one, fourth one, we are having the tertiary groups. We are having the tertiary groups. So what are the tertiary groups? Tertiary groups means carbon having free valency, carbon having free valency attached to 3 carbons. It is attached to 3 carbons. Now you see here this is CH3, now this is carbon, this is CH3, now this is carbon, and it is having the free valency here. This is free valency. Then we can say this as a 3 degree or tertiary. Clear? Now CH3, C free valency, CH2, CH3, and it is a CH3. Clear? Now this one we can say it as a tertiary pentyl, because from the 5 carbon 1 hydrogen is left, right? Done. Now this one we can say it as a tertiary butyl. This one we can say it as a tertiary butyl. Okay. Now next we will see the different types of the alkali groups. Different types of the alkali. Alkali groups are forming from the alkanes only, right? Now alkali groups. Alkali groups. When hydrogen is removed from alkane, when the hydrogen is removed from the alkane, then alkyl group alkyl group is formed. Then the alkyl group is formed, right? Now you see, first one is the alkane. What is the general formula? Cn H2n plus 2 gives rise to which one? Alkyl. What is the alkyl formula? Cn H2n plus 1. Cn H2n plus 1. Already I explained you. CH4 by the loss of one nitrogen, that it will become CH3, that we can say it as a methyl. Okay, done. Now CH3 already, if it is explained, now already I was explained, this one will become ethyl. Done. Now sir, once again why you are explaining? Why I was explaining means, now comes to the propane. CH3 CH2 CH3. Done. Now this propane, free valency is attached here. If free valency is present either any of the last carbon, then we can say this as a N-propyl. N-propyl. Then another isomer means this propane can be exist in the another isomer. How? CH3 CH and CH3. Now if the hydrogen is removed from here, in this internal, if you remove the hydrogen, this one will become iso. Sir, how it will become the iso? What I said, 1 2 3. This is last second carbon, CH3 CH, here the free valency, here the CH3. This is 1 2. Last second carbon, if it is having the what? Methyl group and the hydrogen, then we can say this as a iso, right? This is isopropyl. Done. Next we'll go with to the which one? Next we'll go to the butane. CH3 CH2 CH3. Done. Now for this butane, if you remove the hydrogen at the last end, and it will make it as a, it will become N-butyl. Clear? Now the same thing for this CH3 CH, and if you make the valency free in the which one? Internal carbon, then it will become secondary butyl. Which secondary butyl? Active secondary butyl. It will become active secondary butyl, because this carbon, here methyl, here it is ethyl, here it is hydrogen, here it may be attached to any A group, then it will become active secondary butyl. The same butane CH3 CH3, it will be exist in the another type of the isomer. How? It will be exist in this manner. CH3 CH2, here it is a CH3, here it is a CH. Now it will be the CH3. Now this is a which one? Isobutane. Now this isobutane will be exist, or we can remove the, or we can make the free valency from the last carbon, right? Here if I make the free valency, name of this one will become isobutyl. Clear? If I make the free valency from this internal carbon, if I make the free valency from the last carbon, iso, if I make the free valency from the internal carbon, it will become CH3 CCH3, here it is a CH3. Now it has become the free valency right here. Then what I said, if the carbon is attached with the three different carbons are the three carbons, then we can say this as a tertiary, right? This one we can say it as a which one? Tertiary. This is tertiary butyl. Clear? Now comes to the which one? Pentane. Now pentane is C3 CH2 CH3. This is the pentane. Pentane will be exist in the three types. What are there? First one, this is straight chain. Second one will be the CH3 CH3 CH2 CH3. this one is the isopentane. For this isopentane, if I was remove the hydrogen from here, this one will become CH3, CH, CH3, CH2, CH2, and here it will become free valency. Then it will, this one we can say it as a isopentyl. Isopentyl. If I make the hydrogen free from this internal carbon, if I make the hydrogen free from the internal carbon, now you see CH, which one? CH2, and here if I make the hydrogen free from here, if I make the hydrogen free from here, and it will become CH3. Clear? Now this one will become what? This one will become what? Now you see CH3, here CH3, and here it is a CH2, CH. Means this carbon is attached with the 3 carbons, right? Then we can say this as a 3 degree or tertiary pentyl. This one will become tertiary pentyl. Done? Now next, the same thing for the isopentane only. For the isopentane only, we can make it as a CH3, CH3, here the H, CH2, CH3, and next we can make the free valency here, CH3, CH2, CH, and here it is a CH3, and last I was made the free valency here. Last I was made the free valency. Now in this case you see, here the free valency I made it as a last carbon, which is here. Now here I was made the free valency methyl group next carbon, Now this one will be the, you can see this is active because 4 different groups are there. This is active, then we can say this as a active amide. Next one, here we are having the CH3, CH, CH3, CH, and here the free valency, and it is a CH3. In this manner also we can say this is active iso secondary amide. Active iso secondary amide. Next, last type of the isomer for the pentane, neopentane, right? This is neopentane because 4 groups are attached, 4 carbons are attached to the 1 carbon. So this is neopentane. Okay, neopentane. If you remove any of the hydrogens, all the 4 hydrogens are same. All these 4 carbons hydrogens are same. If you remove any of the hydrogen, then the name of this compound will become neopentyl. It will become neopentyl. Clear? Done. Next one we are having common namings for the alkenyl groups. For alkenyl means double bonded. If suppose double bond they have given, how to give the common naming for this one? Alkene, general formula CnH2n. If you remove one hydrogen, it will become alkenyl, CnH2n minus 1. For this one, CH2 double bond CH2. This is which one? Alkane or ethane. If you remove one hydrogen, this common name we call it as a vinyl. This common name we call it as a vinyl. Next, CH3, and here if the hydrogen, if it is removed and this is double bond, clear? Normally, clear? Now here it is which one? This one we can say it as a which one? Propane. This one we can say it as a propene. In this manner we can say this is a propene, and the propene common name we can say it as a isopropynyl. Clear? Now for this isopropynyl, if I made the free valency here, or isopropynyl or propene, if I made the free valency for this carbon, now you can say CH2 free valency, CH double bond CH2, CH double bond CH2. and this compound we call it as a allyl. This one we call it as a common name for this one will become allyl. Then allyl or propenyl. Allyl or propenyl. This is very, very important. Now third we are having the which one? Alkynyl. Now next we are having the which one? Alkynyl group. Now what is the alkynyl group? This is alkyne CnH2n minus 2. Now from this if you remove the one hydrogen it will become alkynyl. Alkynyl formula will be CnH2n minus 3. H2n minus 3. Now you see this is CH triple bond CH. This is ethyne. If I remove one hydrogen it will become ethynine. It will become what? Ethynine. Ethynine. This is a CH carbon triple bond CH. This is propyne. This one will become propenyl. This one will become propenyl. Done? Clear? Next one. Now next one, alkylidene. Alkylidene group. Alkylidene group. What is the meaning of alkylidene group? Means if you take the alkane CH4 or if you take the any alkane, from this alkane if you remove the two hydrogens, then it will become alkylidene. If you take the CH4, this is methane, right? If you remove the two hydrogens, then it will become methylene. This one it will become methylene. Clear? Done? Now, next. Common name of next one we are going to see the common names of dihalides. Common name of dihalides. Common names of the dihalides means if the same carbon, if one carbon, two halogens are attached. For the one carbon, two halogens are attached, then we can say this as a gemidihalides. Gemidihalides or geminal dihalides. Clear? Now, our common name for this one, this is very, very important. Common name for this one will be the alkylidene halides. Alkylidene halides. Because one carbon, two hydrogens has replaced with the halogens, right? So alkylidene halides. Alkylidene halides. So name of this compound will be the ethylidene chloride. Ethylidene chloride. Done? Ethylidene chloride. Clear? Now let's suppose if they have given in this manner CH2X or CH2Cl they have given, then the name of this one will be the methylene chloride. Methylene chloride. Clear? Now next type of the dihalides. If the halogens are attached to the two different carbons, then we can say it as a which one? Vicinal dihalides. We can say this as a vicinal dihalides. If the halogens are attached to the same carbon or geminal, if the halogens are attached to the two different carbons, then we can say it as a vicinal. Clear? Now common name for this one. Common name. Alkyline halides. So naming for this one CH3, CHI, CH2I. Name will be the propylene iodide. Clear? CH2X or CH2X if they have given. Name of this compound will be the ethylene ethylene halide, ethylene halide. Clear? Now these are the some common names which we are going to use in our IUPAC. Now one, identification of, first we'll go with the identification of parent carbon chain. For any organic compound, identifying of the parent carbon chain is very important. So this parent carbon chain, I was saying it as a PCC. Then identifying of the parent carbon chain. How to identify the parent carbon chain? Longest carbon chain. Longest carbon chain is known as a parent carbon chain. First of all, if I was given this compound and here we are having the, clear? Now you see, give the numbering. Here itself you have to give the numbering. Now 1, 2, 3, 4, 5 we are having. Now if you choose this as a parent carbon chain, 1, 2, 3, 4. Clear? Now what I said, more number of carbon should be present in the chain, right? So this one will become the parent carbon chain. This one will become the parent carbon chain. Then next, if suppose if they have given in this manner, then how to identify the parent carbon chain? Now if you give the numbering from here, 1, 2, 3, 4, 5. If you go left side, it will become 4, 5 only. If you go right side, it will become 4, 5 only. Both are same. Then if you start the numbering from here, 1, 2, 3, 4, 5. It is also 4 and 5. Clear? In the everywhere you are getting same, right? Everywhere you are getting same. So you can take this as a parent carbon chain. You can take this as a parent carbon chain. If not, you can take the parent carbon chain, this one also. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Clear? Now, next type of the parent carbon chains. Now we'll see. Here, after identifying the parent carbon chain, then we have to give the numbering. Numbering for the parent carbon chain. Numbering for PCC. How to give the numbering for the PCC? Then after that we have to write the names. First of all, if suppose, let's suppose if they have given, clear? Now this compound they have given and we have given the one substituents here or two substituents we have taken. Done? Clear? Now give the numbering. If I start the numbering from here, first identify the which one? Longest carbon chain. If you start the numbering from here, 1, 2, 3, 4, here it will become 5. This is not the longest carbon chain. Then if you start the numbering from here, 1, 2, 3, 4, 5, 6. Now if you go it here, 3, 4, 5, 6. Clear? But this is not the longest carbon chain. This is not the longest carbon chain. Then if you go the numbering from here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Clear? This is a longest carbon chain. But is this numbering is correct or wrong? Now whatever the numbering we have given, it is wrong. Why? Because now you see here, whatever the numbering we have given, it is correct, but you may get a doubt. Sir, why not we can give the numbering from the, you have given the numbering from left to right. Sir, why not you cannot give the numbering from the right to left? So I will give the numbering from here. 1, 2, 3, 4, here 5, here 6, here 7, here 8, and here it is a 9. Clear? Now left to right, it is in the yellow, 1 to 9. Now right to left, it is in the white, it will be from the 1 to 9. So which numbering is correct? Left to right is correct or right to left is correct? To identify that one, now after identification of the parent carbon chain, here this is a parent carbon chain, right? Clear? Now this is a parent carbon chain. This is our parent carbon chain. Now after the parent carbon chain, now these two are the substituent. Other than parent carbon chain, if it is present, those are substituent, right? Clear? Now these two are the substituent. Now which substituent these two are? Which substituent these two are? Now these two are the methyls, right? CH3 bond. Now you can see this is carbon, this is carbon, and here we are having the 3 hydrogens. Here the 1 hydrogen, 2 hydrogen, and the 3 hydrogen. Clear? Now these are the methyl groups. Means this is methyl, right? So these two are the methyl substituent. So according to the IUPAC, when you are numbering the PCC, the first point you have to remember, that is substituent should or branching should get least number. Branching should get least number. This is the first point you have to remember. Whenever after identifying the which one longest carbon chain, second point you have to remember that if the branching is present, branching should get the least number. Branching should get the least number. Then now if you give the numbering in the yellow, if you follow the yellow color numbering, branchings are getting 3 and 5. Branchings are getting 3 plus 5. If you go to the numbering from the white color or right to left, now branchings are getting 5 and 7. So what I said, it should what? Substituent should get the least numbers. Or when you add, if the two substituents are there, if you add the numberings of the substituents, should get the least number. That we call it as a locant sum rule. Clear? Now that branching should have the locant sum rule. Lowest locant sum rule it should be there. See, in the yellow you are getting 3 plus 5, it is giving 8. Now in the right to left, in the white it is giving 7 plus 5, it is 12. So in the right to left it is getting the branchings are getting 12. Now in the left to right, branchings are getting 8. So the numbering is correct from the left to right. Clear? The numbering will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Clear? In this manner we have to give the numbering for the compounds. Clear? Now next we will see the another type of the, we'll take the another example so that it will be clear for you. Clear? Now here we are having done. Now 3 substituents are, now which one is the parent carbon chain? Now we have to see. If you start the numbering from here, 1, 2, 3, 4, 5. Done. Next numbering you start it from here, 1, 2, 3, 4, 5. Okay, done. Now if you start it from here also, you will get the same numbering, 1, 2, 3, 4, 5. Everywhere the numbering is same. Then if you start the numbering from here, from now we have given the numbering from left to right. Now start the numbering from right to left. Here 1, here 2, here 3, here 4, here 5. Now check the locant sum rule. Now substituent should get the least number, right? Now check the locant sum rule. In the red case or left, right to left, substituents are getting 2 and here it is 4, right? 2 and 4. Now here what it is getting? Here also the numbering we are getting 2 and 4. 2 plus 4. 2 plus 4. Clear? Done. Now anywhere the numbering is same. Anywhere the numbering is same. So that the parent carbon chain and the numbering we can give either from the left to right or right to left. Then you will get the confused. Then you will get the confused. See, now 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Clear? Now the numbering will be from the left to right or right to left. Then you may get a confused. Then what you have to decide, here the more the substituents, for this one carbon we are having the more the substituents, right? More the substituent should get the least number. More the substituent should get the least number. You can see here what it is happened, 2 plus 4 plus 4. Here the two substituents are there, right? Here 1, here 1. It is getting 4 and 4. If you give the numbering from which one? Right to left. 2 substituents. If you give the numbering from left to right, now the substituents are getting 2 plus 2 plus 4. 2 plus 2 plus 4. Then the overall locant sum rule is 8. Here the overall locant sum rule will become 12. So the numbering will be from the left to right only, not to right to left. So the numbering will be followed 1, 2, 3, 4, 5. Clear? In this manner you have to cross check. Clear? Now next we will go with the another example. With this example, now whatever the misconceptions or whatever the concept you have not understand, it will be clear for you. Now you see, if suppose now already I explained you very clearly about this bond line notation and which one, bond line notation and condensed form. So every time writing in the condensed form or dash line notation, it will be difficulty for us. So identifying of the which one, bond line notation is very easily clear. Now you see, first identify the which one, parent carbon chain, and give the numbering so that the substituent should get the least number. So if you start the numbering from here right to left, now numbering will be from the right to left. Here 1, 2, 3, 4, 5, here it will go 6, but here 6, 7, 8. Done. So here it will be the 6, here the 7, and here it will be the 8. Now you see the where are the branchings we are having. Here the one branching we are having. Here the two branchings we are having. So here the two branchings. Here also two branchings we are having. So give the numbering. 2 plus 2, because two branchings we are having. So 2 and 2 we are giving. Plus here 5 plus 5. In the right to left we are having the 2 plus 2 and the 5 plus 5. Now start the numbering from now left to right. Now give the numbering from left to right. If you are giving the numbering from the left to right, here 1, here 2, here 3, here 4, here 5, here 6, here 7, and here it will be the 8. Numbering will be 4 plus 4 and 7 plus 7. 4 plus 4 and the 7 plus 7. So now white one numbering is correct or red one numbering is correct. So red one numbering will be 2 plus 2, 4 and 10. It will be 14. Locant sum rule we got it as a 14. Now white one numbering 8. 8 plus 14. It is giving 22. So the locant sum rule will be from the red numbering, right? So the numbering will be starts from, now once again I will write the compound. So the numbering will be from here 1, 2, 3, 4, 5, 6, 7 and 8. Clear? Now this is a correct numbering. Clear? Now we got how to identify the parent carbon chain and how to identify the numbering of the parent carbon chain if the substituents they have given. Now we'll start the naming of the which one? Organic compounds. First naming of the organic compounds. How to start the naming of the organic compounds? To start the naming of the organic compounds, whatever the formula I was given, just you remember that formula. Whatever the data they have given in that, if it is present, make it as right. If it is wrong, make it as strike. Clear? Now how? Now we'll see. First we'll go with the simple example. Just a simple example. This one will go. Now either you give the numbering from left to right and the right to left. Everywhere substituent is getting the same number. If I go the numbering from here 1, 2, 3, 4, 5, substituent is getting 3. If I go the numbering and if I give the numbering from here 1, 2, 3, 4, 5, everywhere the numbering is getting same. So now how to start the naming of this compound? First write the formula. What is the formula of the IUPAC? 2 degree prefix plus 1 degree prefix plus root word plus 1 degree suffix plus 2 degree suffix. Done? Now you see, first one, 2 degree prefix is there. 2 degree prefix will say about which one? Substituent. Now this is a parent carbon chain. Other than parent carbon chain, if it is anything, if it is present, that all are the substituents. So which substituent this is? This is CH3. Now this is CH4, methane. Already I explained you in the common names. From the methane, if I remove one hydrogen, it will become methyl. It will become methyl. This is free bond is attached to the parent carbon chain. Now this free bond is attached to the parent carbon chain. So this group is methyl, right? So this is substituent. Now while you are naming the IUPAC, This notation you have to remember and you have to follow for all the IUPAC. What is the notation you have to remember? First, whenever you are representing number means one or more substituents if it is present, same, then number comma number and number you have to give the comma, then number hyphen and a letter. Clear? Then letter and letter there should be no gap. These three notations you have to remember and you have to follow. Number comma number hyphen letter and letter. Clear? Now you see how to identify this one. While writing the IUPAC, you will be get acquainted. First one, 2-degree prefix is there? Yes. Which prefix? Which one? That is methyl. And which position it is present in the parent carbon chain? Third position. So what I said, number hyphen letter, right? 3 hyphen methyl. Clear? Now, is there 1-degree prefix? 1-degree prefix will say about the ring, bicyclo and the spiro. There is no any ring compound here. Cancel out. Then after that plus root word. Root word means root word will be given to the parent carbon chain containing carbons. Parent carbon chain containing carbons only the root word we have to calculate, not the substituent carbons. Remember. So here 1, 2, 3, 4, 5. 5 carbons means what? I said pent, right? PNT. That clear? Now in the organic compound, are you seeing any double bond? Are you seeing any triple bond? Are you seeing any functional group? Clear? No, right? Only all the bonds you are present in the parent carbon chain is straight chain. Clear? Are single bonds only. If it is all the carbon and the carbon, if it is single bonds, then 1-degree suffix will say it as a ane. Clear? Now, is there any functional group in this compound? No. So strike the 2-degree suffix. Clear? Now, combiningly, you write the name. 3 methyl. So letter and letter there should be no gap. 3 methyl pentane. The name of this compound is 3 methyl pentane. Simple. 3 methyl pentane. That's it. Done. Now, next very simple compound will go now. Just now we have seen this compound, right? Just now we have seen this compound. So the numbering will be starting from here 1, here 2, here 3, here 4, here 5, here 6, here 7, here 8. Better now only you have started, right? So I will not go with the somewhat complicated. Just simple one will go. Clear? Now this is which one? Longest carbon chain. Now, in that longest carbon chain, same thing. Again, you write the formula. 2-degree prefix, 1-degree prefix, plus root word, plus 1-degree suffix, plus 2-degree suffix. See, until you get acquainted with the formula, still that time you just write. Now, see the substituents first. Which positions the substituents are there? 2 and 5 positions are there. Now, already I said you, number, comma, number. So, 2 position and the 5 positions we are having the substituents. So, the numbering will be 2, 2. Clear? Next you have to represent the letter, right? So, you have to represent the hyphen. Done. Then after that, which substituent these are? This is methyl and this is methyl. Clear? But 2 times it has been repeated in the organic compound side. So, 2 times if it is represented, we have to use it as a di. If it is 2, if it is 3, try. Clear? Done? Now, here 2 times it has been represented, right? Then we have to represent it as a di. Di 2, 2, dimethyl. Now, root word how many carbon? 8 carbon, right? So, oct. And all are single bonds, ane. 2, 2 dimethyl octane. 2, 2 dimethyl octane. Clear? That's it. Now, next type of the compound will go. Next type of the compound. Clear? Now, this type of the compound they have given. Now first identify the parent carbon chain, then give the numbering that substituent should get the least number. If I go the numbering from here 1, 2, 3, 4, 5, 6. Okay. Now if I go here 5 and 6, 5 and 6. Clear? Then here also you are getting the 5 and 6, and here also you are getting the 5 and 6. But here you are getting somewhat, if you choose this as a parent carbon chain, this one will become the complex substituent. How to name the complex substituent? I will explain very clearly. If in the question, if they ask with the complex substituent, then you choose this as a parent carbon chain. Then according to the IUPAC name given in the option, you have to choose. If suppose they have given the, if you have chosen this one as a parent carbon chain, and whatever the IUPAC you got, that if it is not present in that one, then choose the IUPAC or parent carbon chain in this manner. Then if you choose this parent carbon chain, whatever the option you have seen in the question, that it will be present. Then if suppose if they want to ask in the complex, they will ask you, they will mention it is as a complex. Now if you consider this as a parent carbon chain, now check whether the substituent get the least number or not. Now what the substituent we got? 3, 4 and 5 plus 5. If you choose the numbering from the yellow one, then if you choose the numbering from the which one, this is right to left. If you go it from the left to right, numbering will be 1, 2, 3, 4, clear, and this is 5 and this is 6. Numbering we are getting 2 plus 2 plus 3 and plus 4. Then left to right we are getting the least number, right? 4, 4 plus 4, 7. Here we are getting 10, 14 and the next one we are getting the 17. So right to left numbering is wrong. Now left to right numbering is correct. Now the numbering will be and now numbering will be from the left to right. 1, 2, 3, 4, 5 and 6. Here now different types of the substituent is as present in our parent carbon chain. This is methyl. This is also one type of the methyl and this is also one type of the methyl. Clear? Two methyls are there. Now this is which substituent? Now already I explained you. C2H6. This is ethane. If you remove one hydrogen from the ethane, it will become ethyl. Now this is a ethyl substituent, right? Ethyl substituent. Now here the naming. Whenever you are naming the substituent, here you have to follow the alphabetical order of the substituent. Clear? If two different branching is present, now first give the high priority to the that substituent or that branching which comes first in alphabetical order. In the alphabetical order, which one will comes first? For that one we have to give the high priority. Clear? That one we should give the high priority while writing the IUPAC name. Clear? Now here this ethyl is at the 3 position, right? This ethyl is at the 3 position. Now the naming of this compound will be first one. Ethyl is at which position? 3 position. So 3 ethyl. Then after that again you have to represent the another branchings also. You have to represent their numbering. So you have to give the hyphen. Now in which positions that branchings are present? Now 2 comma 2 and 4. Clear? In the 2 comma 2, 2 methyl groups are there, and fourth position also methyl group is there. So 2 comma 2 and 4, 2 comma 2 and 4. How many methyls we are having? 3 methyls we are having, right? Then we are representing the number. After that we are representing the letter, right? So we have to use the hyphen. And how many methyls we are having? Trimethyl. Clear? 3 ethyl, 2 comma 2 comma 4. Trimethyl. How many parent carbon chain we are having? 1, 2, 3, 4, 5, 6. 6 means ex. All are single bond. So hexane. 3-methyl, 2 comma 4. Trimethyl hexane. Clear? Now in this manner we have to write the name and the next compound will say. If they have given in this manner. Done. Here they have having the 1 year and the 1 substituent here. Clear? Now here if you choose the parent carbon chain, this one 1, 2, 3, 4, 5, 6, 7. If you go it are also 6 and 7. Anywhere it will be same. If you choose the parent carbon chain, this one also it will be same. If you choose the parent carbon chain, this one also it will be same. Then numbering whatever I was given, it is correct or wrong. Now you see here 1, 2, 3, 4, 5. Right to left numbering will be 1 to 7. Now left to right I will give the numbering here. 1, 2, 3, 4, 5, 6 and 7. Done. Now left to right numbering will be 1 to 7 also. In the right to left substituents are getting numbering 2 plus 5. Now in the left to right, now branching is getting 3 plus 6. Clear? Here we are getting what? Here we are getting which one? 7. Here we are getting 9. So which one is correct? Right to left is correct or left to right is correct? Now right to left is correct, right? Because branchings are getting least number. Then how to name this one? This left to right numbering will be wrong. Then how to name this one? But here we are having the methyl substituent. Here we are having the ethyl substituent. So according to the alphabetical order, the first which substituent will come, that you have to write in the first, right, in the IUPAC name. So it is present at the which one? 5th number. So this is 5-ethyl and 2-methyl, because E will come first after the M, right? So 5-ethyl, 2-methyl. How many carbons are there? Hepto. All are single bond. So this is heptane. Clear? Now next with this example we'll go. Let's suppose they have given this one. Then how to name this compound? Here 1, 2, 3, 4, 5. If you choose the parent carbon chain, this one, or if you choose the parent carbon chain, both are same only. Now you see these 3 positions we are having the substituents, right? This 3 position we are having the substituents. Now 3 position, what are the substituents we are having? Ethyl substituent. Now you see this is CH3 and here this carbon with 2 hydrogens. So this is C2H5. So 2 ethyl substituents we are having. Which position we are having? 3 position we are having. So how to name the naming? 3, 3, 2 substituents we are having, and 2 substituents if it is having, so we have to represent it as a diethyl. How many carbons we are having in the parent carbon chain? Hept, and it is all are single bond. So 3, 3 diethyl heptane. Now let's suppose if they have given in this manner N means here 1, 2, 3, 4. There is no any substituent. All are parent carbon chains only. So how many carbon? But. All are single bond. So it is butane. That's it. Simple. Done. Now this is about the which one? This is about the alkane. This is about the alkane. No. Just now I explained you. If suppose any, which one? If suppose any complex branching, if they have given IUPAC naming of complex branching. If the complex branching is present, if the complex branching is present in the parent carbon chain, how to write the IUPAC name for it? How to write the IUPAC name for it? For that one, first of all, how to write the complex branching? For that complex branching, we are having the IUPAC name as well as the common name. Both will be accepted by the IUPAC. Clear? IUPAC name is also accepted for that branching one, and common name is also accepted for that one, IUPAC name for that complex branching. See, if suppose here, let's suppose here the parent carbon chain they have given. For this parent carbon chain, if this type of the complex substituent is present, this is the one complex substituent. Clear? Then IUPAC name for this complex substituent. What is the IUPAC name for this complex substituent? Now you see, first you have to identify the which one? What? Longest carbon chain. If you go 1 and 2, if you go 1 and 2, both are same. So this is 1, 2. And one position substituent is present. One position substituent is present. Which substituent? Methyl substituent. And these two carbons. So 1 methyl. Now parent carbon chain 2 carbon. 1 methyl ethane. This complex substituent. What? This complex substituent IUPAC name is 1 methyl ethane. 1 methyl ethane. Done? No, this complex substituent IUPAC name is 1 methyl ethane. Then common name already I explained you. Here for the carbon, if any free substituent, if it is having the one hydrogen and the methyl, one hydrogen and the methyl, and if the free substituent it is there, this type of the group we call it as a which one? Isopropyl. The common name will be the isopropyl. Done. IUPAC name will be the 1 methyl ethane and the common naming will be the isopropyl. Done. Now in this manner we have to give the IUPAC name. Now I will write the some examples very clearly here. Now we will see. First one, PCC, here the CH, here the CH3, and here it is a CH3. Now IUPAC name will be the 1 methyl ethyl. Now common naming will be isopropyl. Common naming will be the isopropyl. Done. This is IUPAC name. Now this is a common name. Anyone we can use. Then next compound, if suppose if they have given PCC and here it is a CH2 and here it is a CH and here it is a CH3 and here it is a CH3, if suppose if they have given, then naming of this compound will be here 1, 2, 3. So this one will be the 2-methyl propyl. Sir, why you are saying this as a propyl? Because here parent carbon chain, one it has free valency, right? Here it is having the free valency and this is a complex substituent. Clear? That's the reason 2-methyl propyl. Name for this one will be the isobutyl. Done. Now next one, PCC, and now here the CH, here the CH3, now here the CH2, now here the CH3. Clear? Now this common name you can see. This one will be the 1, 2, 3. This one will become 1-methyl propyl will be the IUPAC name. But common name will be, already I explained you, free valency, and if the carbon, if it is having what? Carbon if it is having the free valency, and that if it is attached to the two carbons, then it will become the secondary butyl. Clear? Now next, if PCC and this carbon, if this carbon is attached with the, in this manner, this type of the complex substituent, if they have given, naming will be 1 2, anytime it will be, anywhere it will be here 1 2, anywhere it will be same, then 1 comma 1 dimethyl, 1 comma 1 dimethyl ethyl, 1 comma 1 dimethyl ethyl is the which one? Complex substituent IUPAC name. Now here common name for this one will be the tertiary butyl. Tertiary butyl is a common name. Clear? Now you see. So in this manner we can identify the which one? Complex branching, common name and IUPAC name. So I will give you the very important points whenever you are writing the IUPAC name for the complex substituent with the compounds. It will be very clear for you. Just to remember that one I was given over there. First points you have to remember. These points are very important. Important points to remember while you are naming the complex substituent. These points you have to remember. First one, complex substituents is always written in a square box. Or square bracket. In the square bracket only the complex substituent should be written. So already I said you write both IUPAC and common name. Both IUPAC and common name is accepted. Clear? Now most preferable is IUPAC only. Better will go with the IUPAC only. If you are getting the difficulty with the common name, better you go with the IUPAC. IUPAC giving to the complex substituents is not at all a difficulty for you. Clear? Then third one, for complex branching, if more number of branching is present, more the number of complex branching is present, then here we have to, then more the number of branching is present, then we have to give the di, tri, tetra considered alphabetically. Clear? If two or more same complex branching are present, if two or more same complex branching is present, if two or more same complex branching is present, then we have to use, instead of di we have to use bis, tris, and if it is having the 4, it is a tetrakis. Clear? Now out of the which one? Out of the bracket. These are the points you have to remember to write the complex substituent for the which one? IUPAC name. With the examples it will be clear for you. First of all, with a just well-known example for you. If this type of the substituent they have given. Now this is a longest carbon chain. Now if you go the numbering here 1 2 3 4 5, 6, 7. If you go the left to right and the right to left, complex substituent is getting same only, number 4. So this is a complex substituent, right? Then what is the first point I said? Complex substituent should be represented in the square bracket. Now at which position it is there? 4th position it is there. So 4. Next, it is to be represented in the square bracket. Now what is the complex substituent? This one, this is 1 and this is 2. This is 2. This is 1 and this is 2, right? Then complex substituent 1 methyl, 2 carbons means ethyl. 2 carbons means ethyl. Done. 1 methyl, ethyl, and we have to close the square bracket and followed by the parent carbon chain. Followed by the parent carbon chain. Parent carbon chain F2, ILR single bond, so F10. 4, 1 comma 1 methyl, ethyl, F10. 4, 1. Clear? Done. Next, if suppose, if you want to write it with the which one common name, what is this common name? Now this is hydrogen, and 1 methyl it is present, right? This is 1 hydrogen and 1 is methyl. So 4 isopropyl F10. In this manner also you can write. So better you go with the which one IUPAC name only. Next type of the complex substituent they have given. Now next we will go with this one type of the complex substituent. Okay. Now 4th position we are having this one. One extra branchings also present. Are also present. Now you see. Here, now start the numbering from here. If you give the numbering from here, 1, 2, 3, 4, 4 you are getting, 5, 6, 7 you are getting, 8 you are getting, 4, 7 and 8 you are getting. If you start it from the, which one? Right to here, right to left. Now, here if you start it from here to here, left to right if you start, now, here it will getting 1, 2, 3, 4, 5, 6, 7. 3, 4, 7 is the lowest sum rule. So this will be the correct numbering for this comp. Then here the substituents are there as well as a complex substituent is also there. Substituent as well as complex substituent is there. Then how to write the naming for this one? Now see the complex substituent is at which position? Complex substituent is at the which one? 4th position. So 4. Now which is a complex substituent? Now give the numbering here 1 and here it is a 2. Then represent in the square bracket, right? And here it is 1 comma 1. 2 methyl groups are there. 1 comma 1 dimethyl. 1 comma 1 dimethyl. What is that? 1 comma 1 dimethyl ethyl. Then after that followed by other substituent. Then followed by other substituent, you have to follow the alphabetical order, right? Alphabetical order. This is ethyl and this is methyl. So this is 3 ethyl and this one will be the 7 methyl. This is 3 ethyl. This is 7 methyl. Parent carbon chain. How many? 10, right? Then decane. Clear? In this manner you have to write the complex substituent molecule if they have given. If they have given the complex substituent, now you have to write in this manner. Done? Now one complex substituent I will give you. Now try it from your end and comment this complex substituent IUPAC name in the comment box. So this is a one complex substituent I was given. Try to answer this complex substituent name in a comment box. Okay. Now almost we have seen which one. I will give you some questions. Try it from your end. Now this is one type of the complex substituent. Now questions. First one, second one, okay, this is 2. Now third, okay. Now for this type of questions, now listen, if two different types of the substituents if they have given, like the Br they have given, some chlorine they have given, this 2 will not act as a which one, this 2 will not act as a functional group, this will act as a substituents only, right? Then if this type of the substituent they have given, then how to give the naming for this one? If you go the numbering from here, 1 2 3 4 5, substituents are getting 2 plus 4. If you go the numbering from here, 1 2 3 4 5, 2 plus 4 only. Both the cases substituents are getting 2 plus 4 and the 2 plus 4. Then how to identify which one is a correct numbering, which one is a correct number? Then already I explained you. If two are different or two or more different substituents are present, then the naming should be given according to the alphabetical order of that substituent. Now comes to the here, this is bromo and this is chloro. B will come first, right? So bromine should get the least number. If you follow it in the white one, bromine is getting the highest number 4. If you follow in the red one, bromine is getting the 2 number. So red one is the correct numbering and the white one is the wrong. Then the naming will be here 2 bromo and 4 chloro. How many carbons are there? Pentane. This is a correct naming for this one. Now I will give you the question based on this one. Now try to name the compound. Okay, try to name the compound for this one. Now next, fifth one. Okay, now sixth one, now we'll give the some complex substance. Now this is some complex substituent I was given. Try to name this one. And the seventh complex substituent. Now this is one different type of the complex substituent. Now try to name this complex substance which I was given. Clear? Now try to comment in the comment section how much or how many you have tried. Just you comment in the comment section so that I get to know. We are going to start the IUPAC for the alkenes. Some rules you have to remember. If you remember these rules, now while you are writing the IUPAC for the given molecule, you will not get any confusion. Now what are the first rule you have to remember? If a molecule has unsaturation or the double bond or the triple bond, it should be present in main chain. Then the chain may be longest or small. Clear? Now next, if the molecule has 2 or more unsaturated groups, select all of them in the main chain. Clear? Next, if it is not possible to select all unsaturated groups in the main chain, then select the maximum number of unsaturated groups with a maximum number of carbon atoms in chain. Clear? Now if the molecule has C double bond C and triple bond both, then at least one double bond must be present in the main chain. Clear? If the number of unsaturated groups and carbon atoms are same, then select the chain which has maximum number. Clear? Now we'll follow the one by one rule to write the IUPAC. how to select the PCC selection rule, means parent carbon chain selection rule. Parent carbon chain selection rule, first you have to see, already I was explained very clearly, maximum number of double bonds, maximum number of double bonds should be in the main chain, then maximum number of carbon, clear. Next, maximum number of branching, maximum number of branching or substituent, clear, done. Now you see, what does it mean? If suppose carbon double bond carbon and carbon double bond carbon, and here the carbon, here the carbon, here the carbon they have given, clear. What I said, maximum number of double bonds is the high priority for the parent carbon chain. So this will be the parent carbon chain, this will be the parent carbon chain, and here, and this one will become the, which one? This one will become branching or substituent, branching or substituent, clear. Next, if suppose if it is in this manner, if it is in this manner, next what I said, now select the maximum number of double bonds that should be present in the parent carbon chain with maximum number of carbon. If you select this as the parent carbon chain, now here the two double bonds are there, but how many carbons are there in the parent carbon chain? 1 2 3 4 only. Now next, if you select the parent carbon chain, this one, if you select the parent carbon chain in this one, now you see, here also we are having the maximum number of double bonds, 2 double bonds we are having, and maximum number of carbons are there, right? 1 2 3 4 5 6, right? Here, now this white one will be the, which one? Parent carbon chain, white one will become the parent carbon chain. Now next, if suppose C double bond C, now here bond, here C double bond C, now here C double bond C, and here it is having the some branching, let us assume, let's suppose here it is a branching. Now next, what I said, here if you select this as a parent carbon chain, if you select this parent carbon chain, here it is getting the which one? 2 double bonds and a more number of carbons, clear. But here you are not getting the substituent. And if you select this as a parent carbon chain, if you select this white one as a parent carbon chain, here also you are getting the which one? What you are getting? Here also you are getting the 2 number of double bonds, and as well as a substituent is also getting in the main carbon chain. Substituent should get in the main carbon chain. Blindly believe, substituent should be present in the main carbon chain only, clear. Now here in this manner, this white one will be the parent carbon chain, done. Now second rule, now, rule number 2. What is the rule number 2 is saying? Now rules for numbering the PCC, then how to give the numbering for the PCC. First one, least number given to double bond or triple bond if that is present in the compound, clear. Then next, least number given to substituent or branching, next follow the alphabetical, which one? Alphabetical order, clear. Now what does it mean? Now we'll see. Here let's suppose one CH2, one CH2, and here it is a Cl, if suppose if they have given. Now here one branching is present, Cl is a will not act as a functional group, always it will act as a branching or substituent only. Already explained very clear. Now Here least number is given to the double bond or the triple bond if it is present in that compound. Here the double bond is present, right? Now the numbering will be from this double bond only, 1, 2 and 3. Clear? Next, least number will be given to the substituent. Least number will be given to the substituent. If suppose if the compound is in this manner, now you see here, if you start the numbering from here, 1, 2, 3, 4 you are getting. Here the double bond is getting 2 and 3. Now, if you start the numbering from here, 1, 2, 3 and 4. 1, 2, 3 and 4. Now here also double bond is getting the 2 and 3. If you start the numbering from left to right, double bond is getting 2 and 3. If you start the numbering from right to left, double bond is getting 2 and 3. But if you start the numbering from in the yellow, if you follow the numbering in the yellow color, substituent is getting the higher number. If you are following in the 1, 2, 3, 4 in this manner or left to right, then the substituent is getting the least number, that is 1. So what I said, least number should be given to the substituent. Least number should be given to the substituent. So this yellow numbering is wrong. This yellow numbering is wrong. Now this is a correct numbering. Then if alphabetical order you have to follow. Alphabetical order you have to follow. Means if 2 or more substituent if it is given, bromo and chloro if they are given, first you have to write the bromo, then after that chloro. Now next rule. Now rule number 3. What is the rule number 3? They are saying if 2 or more double bonds, if 2 or more double bonds is present, if 2 or more double bond is present, then use di, tri, tetra before 1 degree suffix and before this di, tri, tetra, etc. Word A letter is used. A letter is used. So what does it mean? Clear? If suppose they have given this compound, now here if you start the numbering from here, 1 and 2, 3 and 4. If you start the numbering from here, 1 and 2, 3 and 4. From anywhere you can start the numbering. So if I start the numbering from here 1, here 2, here 3, here 4. Now here 2 double bonds are having, right? Now write the IUPAC formula. What is the IUPAC formula? 2 degree prefix plus 1 degree prefix plus root word plus 1 degree suffix plus 2 degree suffix. Clear? Now are you seeing any branching? No. Cancel out this one. Are you seeing any cyclic ring? No. Cancel out. Clear? Then how many carbons are there? How many? 4 we are having, right? So this is bute. Clear? This is a bute. Clear? And in which positions double bonds we are having? 1 and 3. 1 and 3. Right? Clear? Now 1, 3. Already I said if 2 or more double bonds are present, then use di, tri, tetra before 1 degree suffix. Before 1 degree suffix. Clear? And before this di and tri, etc. A letter is used. A letter is used. Means for the 1 degree suffix, if you write it as a bute, for that one A letter is used, right? If the 2 double bonds are there, then it will become a buta. And 1 and 3 positions we are having the double bond. 1, 3 di, 1, 3 diene. 1, 3 diene means this compound name will be the buta 1, 3 diene. This is very, very important. In the question they will make you confused. Blindly you will select the option bute 1, 3 diene. This one will also be there in the option. So whenever the same double bonds are 2, 1 or 2 or 3 are the double bonds, if it is present, For the which one 1 degree or root word you have to add. For the root word you have to add the a. Clear? A letter is used. Clear? For the root word you have to add the a. Done. Next, if suppose triple bond they have given. If suppose they have given the triple bond, then the numbering will be 1, 2, 3, 4. Now compound name will be the buta 1 comma 3 two triple bonds we are having, right? Diene. Buta 1 comma 3 diene. Clear? Now next, rule number 4. Now what is the rule number 4? If double bond and triple bond, if the double bond and the triple bond getting same number, then double bond is high priority than the triple bond. Double bond is high priority than the triple bond. Clear? Now what is the compound? Now if you take this compound, now if you start the numbering from here 1, 2, 3, 4, 5. Okay? Now if you start the numbering from here 1, 2, 3, 4, 5. Clear? Now if you start the numbering from the triple bond is getting 1 and 2, double bond it is getting the 4 and 5. But if you start the numbering from the yellow case also 1 and 2, 4 and 5, the multiple bonds are getting. Then in that case what you have to decide? Double bond is a high priority than the triple bond. Double bond is a high priority than the triple bond. Then the name of this compound will become what? There is no substituent, there is no any functional group. So how many carbons are there? 5 carbons are there, right? Pent or 1 or 2. If you may get a doubt, sir, if double bond and the triple bond if it is given, then we should not use I. No, only symmetrical double bonds if it is present, 2 or more symmetrical double bonds if it is present, then only we have to use the which one? A to the root word. We should not use, if the double bond and the triple bond if it is present in the compound, we should not use the A to the root word. Okay? Now this is pent and double bond and the triple bond, right? Double bond and the triple bond. Double bond is present in the which position? 1. No, pent 1 in, pent 1 in and 4 ion. 4 ion. 4 ion. Clear? Then here also one key point you have to remember. See, while I was writing the double bond, here the maximum double bond will be given as a in. Clear? The triple bond will be given as a ion. Triple bond will be given as a ion. But one E I was not represented. One E I was not represented. Means if the oval if it is present, this is a very key point you have to remember. When two ovals is present, if the two ovals is present, remove first oval, clear? Remove the first oval in naming, see, in the in and ein, A, E, I, O, U, right? Clear? Now A, E, Y, I, O, U and the Y is also considered. Clear? The E is the oval and here the Y is also considered. Clear? Then that's the reason the first oval is removed. This E is removed in the while naming. If the 2 or more double bonds are, if any suffix if it is present. Now while doing the number of questions, you will get acquainted with this one. Okay? Now we'll see. Next one. If suppose if they are given in this manner. Now here 1, 2, 3, 4, 5 we are getting. if you give the numbering from here. Then if you go with the numbering from here, 1, 2, 3, 4, 5 you are getting. So double bond should get the least number, right? If you select from the numbering from the triple bond, numbering we are getting 1 and 1 plus 3. 1 plus 3. If you select as the double bond as a high priority, then you are getting 2 plus 4. 2 plus 4. Here if you select the numbering from the triple bond, double bonds are getting the 1 and 3, locate and sum rule 4. If you choose the double bond or double bond as a which one high priority, now the locate and sum rule you are getting the 6. So in this case what you have to do, whenever only when I said you have to choose the double bond as a high priority, if the numbering, if you start the numbering from the triple bond, if it is getting same, if you start the numbering from the double bond, if the numbering is getting same for the double bond and the triple bond, then the double bond is a high priority. But if you start it from the numbering from the triple bond, you are getting the different numbering. Now if you start the numbering from the double bond, you are getting different numbering. So in that case, you have to see the double bond should get the least number only. In that case, what you have to do? Double bond should get the least number. So here this numbering is wrong. So this numbering is correct. Now write the IUPAC name. How many carbons are we having? Pent, 3 in and 1 ion. Pent 3 in 1 ion. Sir, why you are writing the double bond only the first? Why not the triple bond? Now already I said we have to follow the which one? What we have to follow? We have to follow the alphabetical order, right? In the alphabetical order, double bond will come first, then after the Y, right? So first, that's the reason I was returning the double bond first. Done? Now, next. Now we'll do the questions based on this. Whatever the rules we have studied, based on these rules, now we'll do the some questions. Okay? Now this is a one question we have given. Now here the what we have to see, first maximum number should be given to the double bond. So the numbering will be from the 1 and 2 and here it will be the 3. Now going to 4, 5, 6. Okay, here you are getting the next, you have to see the maximum number of carbons should be in the main chain. Here 1, 2, 3, 4, 5, 6. If you go it here it will be the 4, here the 5, here the 6 and here it is the 7. So this one will become the which one? This one will become branching. This one will become branching. Now this one will become parent carbon chain. This one will become the parent carbon chain. Done. Then which substituent this one? Which substituent this one? This is 1 carbon, this is 2 carbon and this is 3 carbon. Clear? 1 CH3, CH2 and CH2 and it is attached to the PCC, parent carbon chain. Now here this one will be the CH3, CH2, CH3. Which one this is? Propane. Propane. From the propane one nitrogen has been removed. Then it will become which one? It will become propyl. It will become propyl, right? Then this substituent is a propyl substituent. This substituent will be the propyl substituent. Now the parent carbon chain we have identified, numbering also we have given. Now substituent also we got to know. Now write the IUPAC name. Got it. 2 degree prefix. So 2 degree prefix plus 1 degree prefix plus root word plus 1 degree suffix plus 2 degree suffix. Now substituent it is there. Yes. At which position it is there? Already I explained very clearly. Number comma number hyphen letter and letter there is no gap, it should be there. This you have to follow while you are writing the IUPAC name. Done. Now 2 degree prefix. Now at which position it is there? 3 and we are representing the, now we are writing the letter, right? So we have to represent the hyphen. Now which letter we are representing? Now substituent, that is propyl. So 3 propyl. Next to root word, how many carbon we are having? F2. Clear? This is F2. And which position? This is done. This is not there. This is done. Now Next we have to represent the either it is a an, in or in. This is in, right? In is present in which position? It is present in one position, right? One in. Clear? Now this is a 3-propyl ep to 1-in. 3-propyl ep to 1-in is a compound name. Done? Now next suppose if they have given if suppose they have given this compound, then start the numbering from here. 1 2 3 4 5 6. Now if you go the numbering from here 1 2 3 4 5 6. Now double bond is getting 2 plus 5 in the white, and in the yellow case 1 plus 5. So 2 plus 5 is 7, here 1 plus 5 is 6. So which one is correct? Yellow one is correct, right? Now the numbering will be from the yellow one. Now this will be the parent carbon chain. Now third position we are having the substituent. Which substituent? Propyl substituent. Done. Now again you give the numbering. 3-propyl, which one? Eggs, 3-propyl eggs. Now one position and the 4 position what we are having? Now double bonds we are having. Then eggs 1, 4, 1, 4, 1, 4 di-in, 1, 4 di-in. Clear? Now this is the name of the IUPAC of that compound. Clear? Next, if suppose this simple compound they have given, simple compound if they have given, now double bond should get the least number, right? So the name of this compound will be the but 1-in, but 1-in. Clear? Now let's suppose if they have given this compound, in this manner they have given this compound. Now here give the numbering 1, this is 2, this is 3, and this is 4. Clear? And the 2 and 3 positions we are having the which one? Substituent, right? Which substituent those are? Methyl substituents. So 2, 3 dimethyl, 2, 3 dimethyl. How many carbons are there? But 2, 3 dimethyl, but 2, 3 di, 2, 3 di-in, 2, 3 dimethyl, but 2, 3 di-in. Clear? 2 and 3 positions we are having the methyl, so 2, 3 dimethyl, but 2, 3 di-in, 2, 3 di-in. This is the name of that compound. Clear? Next, if the triple bond if they have given and one substituent they have given, triple bond they have given and one substituent they have given, then how to give the numbering? Now you can give the numbering from either any of the cases, because both the cases numbering is same. So now third position substituent we are having. Which substituent? 3-methyl, pent 1, 4 di-in, 1, 4 di-in, because 2 triple bonds we are having. Done. Now next type of the compound. No, this is the compound. The next the compound they have given. Okay. Now this is a compound we are having. Now if you start the numbering from here 1 2 3. If you start the numbering from here 1 2 3, 1 2 3. Clear? But what you have to see, maximum number of double bond should be covered in the parent carbon chain. So if you start the numbering from here 1 2 3 4 5. So double bond is getting 2 and 4 positions. Which one? If you start the numbering from white, if you start the numbering from yellow, 1 2 3, here 4 5. If you start the numbering in the yellow case, now double bond is getting 1 and 3 position. Which is correct? Double bond should get the least number, right? So 1 and 3 is correct. 1 and 3 is correct. Now this one is a parent carbon chain. Then parent carbon chain, now this one will be the which one? Substituent. This is which substituent? This one already I explained. 1 2 3 4. 4 carbons means normally it will be the butane. One nitrogen has been lost, right? One nitrogen has been lost. How the butane will be CH3, CH2, CH2, CH3. This is the butane. But here it is attached to the parent carbon chain, right? By loss of one electron. Sir, by the loss of one hydrogen. Clear? This is which one? Butyl. Then you can say this as a butyl. Substituent is butyl. Which position the substituent is present? Third position the substituent is present, right? So numbering will be 3-butyl. 3-butyl. How many parent carbon chain we are having? 5. This is a parent carbon chain, right? Parent carbon chain we are having 5. 3-butyl. How many? Pent. 1 comma 3 diene. Now we will write in this manner, but this one will be the wrong. This one will be the wrong. Why it has become wrong? Now already I said, if two or more symmetrical, either double bond or either same triple bond, if it is present, then for the root word, what we have to add? We have to add the penta, A. So 3-butyl penta 1 comma 3 diene. 1 comma 3 diene. Clear? Now this is a correct IUPAC name. Correct IUPAC name. Done? Now next, last one. If they have given in this manner, then what I said, 1, 2, 3, 4, 5, 6. Okay. Now if you start the numbering from the triple bond, multiple bonds are getting 1, 3, 5. Now if you start the numbering from the double bond, 1, 2, 3, 4, 5 and 6. Here also 1, 3, 5 you are getting. So what I said, if you giving the numbering, if the triple bond and the double bond, if it is present, numbering if you start from the triple bond, multiple bonds are getting the 1 and 3, 1, 3, 5. And if you start the numbering from the which one? Double bond, multiple bond is getting 1, 3, 5. Then in that case, which bond has to be given the high priority? Double bond should be given the high priority. Then the numbering we have to follow in the white one, not the yellow one. Clear? Now this is the parent carbon chain. Now this will be the parent carbon chain. Now if it is this parent carbon chain, 1, 2, 3, 4, 5 and 6. Done. Now write the name. How many carbons we are having? 6 carbons we are having in the parent carbon chain. This is hexa. Then here you should not use the hexa because multiple bond is present. One double bond and one triple bond it is present. Clear? So we should not use which one? A. Hexa 1 comma 3 diene. Now already I explained you. If the triple bond and the double bond if it is present, now one E should be removed in the which one? Double bond case. Clear? Ine. At which position triple bond it is there? 5-ine. 5-ine. Now X 1 comma 3 diene 5-ine. Now this is a which one? Which one? This is a IUPAC name for the given compound. Done. Now this is about the IUPAC for the which one? How to write the alkene and the alkyne. Now we will see the how to write the IUPAC name for the cycloalkanes. IUPAC in cycloalkanes. Now while if suppose any cycloalkane if they have given, now how to write the which one? IUPAC name. Sir, what are the cycloalkanes, sir? Now I will say what are the cycloalkanes. Now if 3-member rings if they have given, now this is cyclopropane. This is cyclopropane. Now 4-member carbons if they have given, this is cyclobutane. Done. Now if 5-member carbons if they have given, this is which one? Pentane. Done. Now if 6-member carbons if they have given, this is cyclohexane. Same again this formula only. Now we have to use 2 degree prefix plus 1 degree prefix plus root word plus 1 degree suffix plus 2 degree suffix. Any substituents are there? No. 2 degree prefix is cancelled. Now 1 degree prefix, ring it is there. Ring if it is present, then we have to use the cyclo. Then root word, how many carbon? 1, 2, 3. 3 carbons, prop. Done. Now all are which one? Single bonds. So en. Is there any functional group? No. Cancel out. 1 degree prefix, root word plus 1 degree suffix, cyclopropane, cyclobutane, cyclopentane, cyclohexane. Done. Now here, if 2 or more alkali groups present in the ring, their positions are indicated 1, 2, 3, etc. Substituent in alphabetical order is given the lowest number. So this is the first rule. Now you see, here these two compounds they have given. First you have to give the numbering. Here which one we are having? Here this is a cyclohexane it is having. For this cyclohexane, 2 substituents we are having. One methyl substituent, this is CH3, one methyl substituent, and here 3 carbons are there. Then this is propyl substituent. This is propyl and this is methyl. One is propyl and one is a methyl. So we have to give the numbering according to the which one? Substituent alphabetical order should get the least number. Which one? Substituent alphabetical order, that substituent should get the least number. Here the M, here the P. Now which one will come first in the alphabetical order? M will come. So that methyl should get the least number. The numbering will be 1, 2, 3, 4. 1, 2, 3, 4. Now numbering of this or naming of this compound, same again, 2 degree prefix plus 1 degree prefix plus root word plus 1 degree suffix plus 2 degree suffix. Now substituents are there. What are the substituent? One methyl substituent we are having, one propyl substituent we are having. Now which position methyl substituent we are having? One position, one number hyphen letter, right? So methyl. Then again you have to represent the number, which position? 4 hyphen, and which is the substituent? 4 propyl. Then done. Then 1 degree prefix it is there because cyclo, this is ring it is there, cyclo. How many carbons we are having? 6 carbon. X, clear? All are single bond, so N. 1 methyl, 4 propyl, cyclohexane. Now comes to this compound. Now this is which one? Methyl. Now here the 2 carbons we are having. This is which one? Ethyl. This is ethyl. This is methyl. Now the numbering will be given to the ethyl or methyl. Now E will come first, right? The numbering will be here 1, 2, 3, 4, 5. Now naming of this compound will be 1 ethyl, 2 methyl, 1 ethyl, 2 methyl, cyclopentane. Clear? In this manner we have to write the naming. Now next, if this type of the compound, both are same only, but numbering we'll see. Here methyl we are having, ethyl we are having. So according to the alphabetical order, first we will go with the ethyl, right? So we will give the numbering here 1, 2, 3, 4, 5, 6. Done. Now here I will give the numbering in this manner here 1, 2, 3, 4, 5, 6. So now if you follow the alphabetical order here, but when only the disubstituent if it is there, methyl and ethyl, but here the trisubstituents we are having, right? Then you have to cross check the locant sum rule also. Even though if you are following the which one alphabetical order, then locant sum rule also you have to cross check. Then if you follow the ethyl one is giving the high priority, then the locant sum rule we are getting 1 plus 3 plus 3. Okay. Then if you give the high priority for this one methyl one, 1 plus 3. Then here the locant sum rule we are getting 7. Here the locant sum rule we are getting 5. So this numbering is wrong and this numbering is correct. Clear? When the trisubstituent if they have given Even though if you are seeing alphabetical order, if the alphabetical order, if it is getting the lowest sum rule, then it is okay. But if it is not getting, then you have to see the one which will give the locant sum rule only. Clear? Then how to name this compound? According to the alphabetical order, ethyl will come first, right? Now E should be written in the IUPAC name first. So this will be the 3-ethyl and 1,1 dimethyl, 1,1 dimethyl. How many carbons we are having? Cyclohexane. Cyclohexane. Clear? Now this is a compound. Done? Now next another rule number 3. What you have to remember? Ring contains more carbon atoms than the side chain. If ring contain more carbon than the side chain, here you see 1, 2, 3, 4, 5, 6. Ring contains 6 carbon. Now the side chain we are having only 1, 2, 3, 4. Then if the ring contain more carbon than the side chain carbon, then ring act as PCC. Then ring act as a PCC. Then this one will be the parent carbon chain. Now this one will be the which one? Substituent. Now which substituent this one? Now write the numbering here. Here give the numbering for this one. Here 1, 2, 3, 4. So one position methyl is there and substituent is there, right? So 1 methyl, butyl, 1 methyl, butyl. Now which one? This is cyclohexane. 1 methyl butyl cyclohexane is the IUPAC name for this compound. Next one. If ring carbon contain less carbons, ring carbon contain less carbon than the substituent carbon or side chain carbon. Now you see side chain carbon we are having how many? 1, 2, 3, 4, 5. 5 we are having. But here ring is having how many? 3. Then ring will act as substituent. Then ring will act as substituent. Is it clear? If the side chain, which one? Side chain carbons, if it is having higher than the ring chain, then ring will act as a which one? Branching. Then give the numbering. Here 1, here 2, here 3, here 4, 5. Now what I said, substituent should get the least number. If you start the numbering from right to left, then what it will happen? It's a substituent is getting the 4th number. So that numbering is wrong. This numbering is correct. Now here how to write the IUPAC name for this one? Now here the ring is acting as the which one? Substituent. This is which one? Cyclopropane. This is cyclopropane. From this cyclopropane, I was removed the one hydrogen. I was removed this hydrogen. Now this group has been attached to the PCC. Now you can see this is attached to the PCC. Now what is the name of this compound? From the alkane, if you remove one hydrogen, it will become alkyne. From this cyclopropane, if I was removed the one hydrogen and it is attached to the parent carbon chain, then the name of this one will be the cyclopropyl. Name of this compound will be the cyclopropyl. Clear? Now give the naming for this compound. How to give the naming for this compound? Now first 2 degree prefix plus 1 degree prefix plus root word plus 1 degree suffix plus 2 degree suffix. Now 2 degree prefix is which one? Substituent, right? Now what is the substituent here? This is cyclopropyl. Cyclopropyl is a substituent. Is there any ring in the parent carbon chain? No. Then root word. How many carbons we are having? Cyclopropyl, pent. All are single carbons, right? Cyclopropyl, pentane. Clear? Now sorry. Which position? Oh, sorry. Now which position that branching is present? 2 position, right? 2 cyclopropyl pentane. 2 cyclopropyl pentane is a naming of this compound. Then in this manner you have to write the naming. Clear? Now here next we'll see the IUPAC naming for the cycloalkene. Now what is a cycloalkene, sir? Now first this one, before it is a which one? Cyclopropane. Now this one, here the one double bond it is there, then it is became cycloprop, but here the double bond it is present, right? Here the all are single bond, so N. Here one double bond is present, so it is in. Now if suppose any triple bond if it is present, then the naming of this compound will be cyclopropine. Why? Here the triple bond is present. Due to that triple bond, here N, in, I. N, in, and I. Now here also. So while you are writing the which one IUPAC name for the cycloalkenes, always give the high priority to the which one? Double bond only. Double bond should be given the high priority. So here naming of this compound. First of all, first identify the parent carbon chain and give you the which one? Numbering. So we may think that substituent should get the least number. So first this will be the numbering we used to give. But what I said, double bond should get the least number I said, but double bond is getting the 2 and 3. So this numbering is wrong. Then when I said the double bond should get the least number 1, 2, 3, 4 and 5. Now what I said, double bond should get the least number, then after that substituent should also get the least number. Here the double bond is getting 1 and 2, but substituent is getting the 5. So this is also wrong. This is also wrong. Now here, now if you start the numbering from here 1, 2, 3, 4, 5, then here you can see what we are getting. Substituent is getting the least number. 1 and 2, substituent is getting the least number, and double bond is getting the least number, and substituent is also getting the least number 3, right? So this is a correct name. This is a correct name. Now what is the IUPAC name of that compound? Now if I want to write the IUPAC name of this compound, now this is 1, this is 2, this is 3, this is 4 and this is 5. This is 5. Now first we have to give the substituent, right? 2 degree prefix. In which position 2 degree prefix is there? Third position, that is 3-methyl. 3-methyl cyclo. Now how many carbons we are having? 5 carbons we are having. Cyclo, pent, and which position the double bond is present? 1 position, right? So pent 1 in. 3-methyl cyclo, pent 1 in. Cyclopent 1 in, or else you can write it as 3-methyl cyclopentene. 3-methyl cyclopentene. Done. Now if suppose if they have given the compound like this, they have given in this manner, then how to write the numbering for this one? Now we may think that numbering we will start it from here, but if you start the numbering from here, now double bond is getting the least priority, but substituent is getting the 2, right? So this numbering is wrong. Then the numbering for this compound will be in this manner. Why? Double bond is getting 1 and 2 and substituent is getting the least number. So naming of this compound will be 1-methyl. Clear? How many carbons we are having? This is cyclo. How many carbons we are having? Buto 1 in. 1-methyl cyclo buto 1 in is the name of this compound. Next, if suppose if they have given this compound, then how to write the numbering? Now we'll start the numbering from here. 1, here we may start the numbering from here. 1, 2, 3, 4, 5. Clear? Then if you start the numbering from here, double bonds are getting 1, 4. 1, 4. Then if you start the numbering from here 1 2 3 4 5. Now the double bonds are getting 1 and 3, right? So this numbering is wrong. This numbering is correct. Clear? The name of this compound will be cyclo, because there is no any substituent. Cyclo. How many carbons we are having? Pent. 5 carbons, cyclopent. And which position double bond we are having? 1, 3. How many we are having? 2 we are having, right? 2 double bonds we are having. 1, 3 diene. Cyclopent 1, 3 diene. Diene. But is it correct? Is the name is correct? No. Already I said you. If the two symmetrical double bonds, if it is present, then for the root word we have to add the letter A. So this is a cyclopenta 1, 3 diene. You have to be very careful whenever the two or more symmetrical dienes or trienes if they have given. Clear? Now this will be the correct IUPAC, cyclopenta 1, 3 diene. Okay. Now next. If suppose if they have given the compound in this manner, then what we have to decide? Already I said you, double bond should only give the least priority. Then this one will be the 1, 2, and this one will become the substituent. Which substituent? Cyclopropyl, right? This is 1 cyclopropyl. Now eth 1 ene. Now this is a compound name. Now next, if suppose the compound they have given in this manner. Now here also one double bond. Ring also we are having the double bond. Now substituent is also having the one double bond. Then if you take this as a parent carbon chain, substituent if you take it as a parent carbon chain, but parent carbon chain you are getting only 2 carbons. But if you start the numbering from here, 1, 2, 3, 4, 5, 6. Now then this one will become the substituent. Then if this one has become the substituent, parent carbon chain we are getting 6. Sir, you may get a doubt. Sir, why only you have given the 1, 2, 3, 4? Why not you have given the numbering from here? 1, 2, 3, 4, 5. If I give the numbering from the 1, 2, 3, 4, 5, 6 in the yellow color, substituent is getting the which priority? High. 5th position we are getting, right? Substituent should get the least priority. Which priority? Least priority. Done. Now, how to write the naming of this compound? Now this one will be the substituent, right? This one will become the substituent. Now this is ethene. Now from this ethene, if I was one hydrogen, if it is removed, then this name will be the which one? Ethenyl. Name of the substituent will be the ethenyl. In the common names, already I explained very clearly. These common names will play very important role. If you have missed that common name lecture, please go and see over there. You will get understand very clearly. So 4 ethynyl cyclohexane 1 ene. Done. Now next, another compound. If this type of the compound if they have given, now double bond should be given the high priority, right? Now 1, 2, 3. Now this ring has become the substituent. Which ring this is? Cyclohexyl. Cyclohexane, right? Cyclohexane. From the cyclohexane, if you remove the one hydrogen, it will become hexyl. Clear? Now, naming of this compound will be 3-cyclohexyl. Now, how many carbons we are having? Cycloprop 1 ene. Cycloprop 1 ene. This is the name of this compound. 3-cyclohexyl cycloprop 1 in. Prop 1 in. Done. Next very important, IUPAC naming in multiple bond is acting as a branching. If the multiple bond is acting as a branching, that it is directly attached to the parent carbon chain, or if it is, what does it mean? Let's see. Here now this double bond in this manner, if the double bond, or better first we will go with this one, and if the double bond is acting as a which one? Substituent. Here the double bond is acting as a substituent. When the double bond is acting as a substituent, then how to name this substituent? How to name this substituent? See, already I explained very clearly. If the parent carbon chain, if the CH double bond CH2, now this is ethane. From this ethene, if one nitrogen is removed, then it will become which one? Ethynyl. If the parent carbon chain, here it is a CH2 and one double bond, if it is given, then this one naming will become prop 2 enyl. Now here the parent carbon chain, if suppose CH double bond CH3, if the given double bond is only directly attached to the parent carbon chain, if the double bond is only directly attached to the parent carbon chain, then the naming of this compound will be, branching of this compound name will be prop 1 enyl. So what is the IUPAC name of this compound now? What is the IUPAC name of this compound? What is the IUPAC name of this compound? Now give the numbering 1, 2, 3, 4, 5, 6, 7. Now this is a substituent, right? Now which substituent this is? 1, 2. So this is 4 ethynyl. How many carbons we are having? Ept. This is ept or epta. Symmetrical dienes are present in the parent carbon chain. This is epta. Clear? 4 ethynyl epta 1, 6 diene. 4 ethynyl epta 1, 6 diene. Clear? Done. Now in this manner we have to write the which one? If double bond is acting as a substituent, if the triple bond is acting as a substituent, the same. If the triple bond is acting as a which one? Triple bond is acting as a substituent, then if the triple bond is acting as a substituent, same thing, PCC C triple bond CH. This is which one? Ethyne. Triple bond is ethyne, right? Then it will become ethyl enyl. Clear? PCC and CH2 C triple bond CH. Then it will become prop 2 what? I9. Prop 2 I9. Name of this compound will be 4 ethynyl epta 1, 4 which one? 1, 4 diene. 1, 4 sorry 1, 4 diene. 1, 4 diene is a compound name. Done. Now next, if multiple bond is directly attached to the, if the multiple bond only if directly attached to the parent carbon chain. Now without any carbon, if the multiple bond only if it is attached to the which one? Parent carbon chain, how to give the naming? Now you see here what it is happened. Here this carbon, it is 2 hydrogens we are having. Now you see normally for the one carbon, This is CH4. This is CH4, right? Now this is methane. For this methane, if I was removed one hydrogen, it will become methyl. Methyl. If I remove the two hydrogens, this one will become methylidene. Clear? This one will become methylidene. Here also directly double bond is attached. Double bond is attached. What? Double bond is attached, right? For the, you see, for this carbon only, for this carbon, I was removed the, for this methane, you can see, for this methane, I was removed the two hydrogens. I was removed the two hydrogens. So that these two bonds has been attached to the parent carbon chain. These two free bonds only attached to the parent carbon chain. Name of this compound will be methylidene. Name of this compound will be the methylidene. Clear? Done. If suppose, if you C double bond, here the which one? C and CH3 if they have given, then the name of this compound will be the ethylidene. Ethylidene. Clear? Then for the methane, if the two bonds directly attached to the parent carbon chain, the name of this compound will be methylidene. Now name of this compound will be 4-methylidene. 4-methylidene. How many carbons we are having? 1, 2, 3, 4, 5, 6, 7. Clear? Hepta 1,4 diene. Hepta 1,4 diene. Clear? So in this manner we have to give the naming. Clear? Before going to start the IUPAC for the functional group, now you have to know the which functional group is the high priority. Why we have to remember the functional group priority order? Because now in our IUPAC, if two or more functional groups if they have given, then which one we have to take it as a functional group and which one we have to take it as a substituent. It means in the IUPAC, what is the IUPAC formula? 2 degree prefix plus 1 degree prefix plus root word plus 1 degree suffix plus 2 degree suffix, right? Now functional group will be said by the 2 degree prefix. If a carboxylic group if it is given and one aldehyde if it is given, then which one will be taken as the functional group, which one will be taken as a substituent? So to know that one, this functional group priority order is the key role it will play. Now in that functional group priority order, you have to remember the functional group priority order. If it is acting as a 2 degree suffix or if it is acting as a main functional group, how to name the 2 degree suffix, and if it is acting as a substituent or if it is acting as a 2 degree prefix, then what is the name? What is the name we have to give it? For that one we have to remember. Now let's listen. Now we'll see. First among all the functional group, the first functional group priority order is given as a, for which one? Carboxylic acid. For this carboxylic acid, if it is acting as a which one? Suffix. If it is acting as a prefix means substituent, then we have named it as a which one? Carboxy. We have named this one as a carboxy. If suppose if it is acting as a main functional group, we have named this as a oic acid. Then next one is a sulfonic acid, SO3H. Now if it is acting as a which one? Substituent, sulfo. Then if it is acting as a main functional group, then sulfonic acid. Then next order will be the acid anhydride. Next order will be the acid anhydride. Acid anhydride, there is no any prefix name. Now if it is acting as a suffix, then oic anhydride. Oic anhydride. Next one will be the ester. Ester, now prefix alkoxycarbonyl. Alkoxycarbonyl. Next, if suppose if it is acting as a functional group, we have alkyl O8 or we can say it as a O8. Clear? Done. Next, acid chloride or we can say this as a acid halides also. Not only chloride, we can take it as a acid halide. Done. Here we have taken the chlorine, right? So chloroformyl. Which one? When it is acting as a substituent. Then if it is acting as a main functional group, oil chloride. Oil chloride. Done. Done. Next, acid amide. Carbamyl. Then it is a amide if it is acting as a functional group. Next it is a nitrile. This is very important. Many of the students they will make mistake when the CN is given. Why? If the CN is acting as a main functional group, name is nitrile. not cyano. Many of the students, they will make mistake here itself. So the name is, if it is acting as a which one functional group, we have named it as a nitrile. If it is acting as a substituent, we have named it as a cyano. Clear? Then next one is a isonitrile. Isonitrile NC. Clear? This is isocyano. Then this is carbyl amine. Carbyl amine. Then next one is a aldehyde. Aldehyde, if it is acting as a substituent, formyl. If it is acting as a functional group, al. Then ketone, keto or oxo, and if it is acting as a functional group, one. Then next alcohol. Alcohol, if it is acting as a substituent, hydroxy. If it is acting as a functional group, ol. Then next is the amine. Amine NH2, amino amine. Then and next these all will be the, this will olefin. Olefin means nothing but double bond. Now acetylene. Acetylene is nothing but triple bond. Clear? Now this will not act as any prefix. Now if it is acting as a functional group, most of the cases it will not act as a active functional group. This will not act as a active functional group. Okay. Now ene, ine. Next this one is a ether, and this all will be acting as only substituents only. There is no any, this will act as only substituents, not the functional group. Already I explained you. Nitro group will act as only substituent, not the functional. We'll see the how to write the IUPAC name for the functional groups. Now first, IUPAC naming for functional group of compounds, or functional group of the compounds. Then functional group containing compounds. First one, the first thing you have to remember, that maximum number of carbon, maximum number of carbon contain functional group is high priority. Maximum number of carbon containing functional group is high priority. Next, maximum number of multiple bonds. Multiple bonds are that double bond or triple bond is high priority. Next, maximum number of carbon. Maximum number of carbon. Clear? Next, greater than maximum number of substituents. Maximum number of substituents. Clear? Now this is the order you have to follow for the naming of the which one functional group. For the naming of the functional group, now this is the order you have to follow. Maximum number of carbon containing functional group. Next, maximum number of double bond or triple bond that containing. Next, maximum number of carbons. If it is same, then you have to see the maximum number of carbons. Then if it is also same, then you have to go for the maximum number of substituents. Now what does it mean? Now you see first. If suppose they have given first to this one. Okay. Now here first, which is the parent carbon chain, you have to see. Now double bond and the alcohol, which is the high priority in the functional group. Alcohol is a high priority in the functional group, we know. So this alcohol should, any of this alcohol should get the least number, not the double bond, Clear? Now if you go it here, what I said, first maximum number of carbon containing functional group, then maximum number of double bonds. Here the 1, 2, 3, 4, 5. If you go it here also 4 and 5. But here you are getting the double bond. But you are getting the which one? Here you are getting which one? Here you are getting the which one? Functional group. So this is the parent carbon chain. This is a parent carbon chain. Then next, if suppose if they have given in this manner. In this manner, if suppose if they have given, then next parent carbon chain will become this one. This one will become the parent carbon chain, because here the maximum number of carbon that containing functional group, here it is having only maximum number of carbon should contain the functional group is a that is the parent carbon chain. Here the maximum number of carbons and it is having the 2 functional groups. So this is the eukaryotic. Then here only maximum number of carbon containing functional group and the double bond in the parent carbon chain, and this one will become which one? Substituent. This one will become substituent. Then next, if suppose if they are given in this manner. So if they have given in this manner, then if they have given in this manner, then which one will be the parent carbon chain? If you see here, functional group should be in the parent carbon chain and it should be the least priority. Then if you go it here, if you choose this as the parent carbon chain, then you can see this what the first thing I said, maximum number of carbon containing functional group, then maximum number of double bond or triple bond, then maximum number of carbon or maximum number of substituents. Now you see here parent carbon chain containing functional group and the one double bond, but number of carbons are 1, 2, 3, 4 and 5 only. But even though we can make in this manner also. See here, if you select this as a parent carbon chain, in this parent carbon chain also you are getting the double bond and you are getting the functional group and more number of carbons. You see 1, 2, 3, 4, 5, 6, 7 and 8. Clear? This one will be the parent carbon chain. Then next one. If suppose any substituent if they have given. Here OH it is there. Clear? Now which one is a parent carbon chain? Then this one will become the parent carbon chain. Maximum number of the substituents it should be in the parent carbon chain. Now this one will become the which one? Parent carbon chain. Now here for the numbering, if you want to numbering the PCC, after identifying the PCC, numbering of PCC, how to give the numbering of PCC for the which one? Functional group containing organic compound. First priority will be given to the least number given to functional group. First least number should get for the which one? Functional group. Next least number to double bond or triple bond if it is contained in that organic compound. Next least number to branching or substituent. Clear? Next we have to follow the alphabetical order. Now this is a numbering for the PCC. Done. Now how to give the numbering? Now we'll see. If suppose they have given this compound, then how to start the numbering? Here we have to start the numbering from where? From the double bond we have to start or the functional group? Functional group should be get the least number. If you start the numbering from here 1, 2, 3, 4, 5. Functional group is getting 5. So this numbering is wrong. Then the numbering will be start from here 1, 2, 3, 4, 5. First functional group if it is present, functional group is should get the least number. Then next. If suppose if this type of the compound they have given, then if you start the numbering from here 1, 2, 3, 4, 5, then functional group is getting the 3 number only. Then if you start the numbering from here 1, 2, 3, 4, 5. If you start the numbering from the left to right, functional group is getting 3, and if you start the numbering from right to left, numbering is getting 3 for the functional group. But if you start the numbering in the white one, if you follow the numbering in the white one, double bond is getting 4 and 5. But if you follow the numbering in yellow, double bond is getting 1 and 2. So what I said, now substituent should get the least number. Substituent or multiple bond should be get the least number. Right? Here the multiple bond is getting least number 1 and 2. So this numbering is correct. 1, 2, 3, 4 and 5. 1, 2, 3, 4, 5, 5. Done. Next, if suppose If suppose if they are given in this manner, then which one is a high priority, or which one we can give the numbering. Now if you start the numbering from here, 1 2 3 4 5, here functional group is getting 3. If you start the numbering from here, 1 2 3 4 and 5, then now in this case left to right also functional group is getting 3, right to left also functional group is getting 3. But here multiple bonds 1 and 2 4 and 5. If you start it from here, 1 and 2 4 and 5, if you start it in the yellow case 1 and 2 4 and 5, then which is a correct priority? Then after that, then what you have said, least number is given to the functional group. Okay, done. Then after least number is given to the double bond and triple bond. Okay, then least number should be get to the branching also, right? Now you see, if you follow the yellow number, branching BR is getting 4. If you follow the numbering in the white, branching BR is getting 2. So which one is correct? White numbering is correct. And now this is a numbering for the following compound. Clear? Now next, if suppose if they are given in this manner, here it is a BR and here it is a CL. Clear? Now if you start the numbering from here, 1 2 3 4 5. If you start the numbering from here, 1 2 3 4 and 5. Now you cross check. What you have to cross check? If you start the numbering in the yellow one case, 1 and 2 4 and 5 for the double bond and the functional group 3, it is okay. But here which numbering is correct? Which numbering is correct? Here to identify the numbering, here the two substituents we are having, one bromo, one chloro. Then you see, first least number is given to the, in any case least number functional group is getting 3, right to left or left to right. Next, least number is getting, should be the multiple bonds. If you follow from the left to right or right to left, 1 and 2 4 and 5, that is fixed. Then least number should be given to the branching, that branching numbers are fixed. Then in that least number should be given to the branching, then we have to follow the alphabetical order. In that, which one we have to follow? Alphabetical order we have to follow. See, here this one is a chloro, this is a chloro. Now this one is a bromo, this one is a bromo. Clear? Now which is a correct numbering? Now bromo should get the least number. So yellow one is a correct numbering or red one is a correct numbering? Red one is a correct numbering, because bromo alphabetically bromo will come first. So bromo is getting the least number. Bromo is getting least number. Now this is a correct numbering for the functional group priority order. Done. Next, very important, you have to remember, very important rule we are going to study. That is, what is the rule? Next rule we are going to study, that is rule number 3. If a carbon containing functional group, if the carbon containing functional group is present, the carbon containing functional group is present yet terminal position. What is the meaning of the terminal position? Starting terminal positions. Now least number or first number should be given. Least number should be given to that, which one? Least number should be given to that carbon containing functional group. Carbon containing functional group should be given the least number. What are the carbon containing least or carbon containing functional groups, sir? Now first one is a carboxylic acid. First one is a carboxylic acid. This carboxylic acid group or this carboxylic acid carbon should be given as a high priority. Then next, aldehyde. Okay, this aldehyde carbon will be given as a high priority. Next, many of the students, they will make a mistake here only. They will not consider the cyanide carbon as a parent carbon chain when the cyanide is given as a functional group. So this cyanide carbon also you have to consider as a which one? functional group, sorry, you have to consider it as a parent carbon chain only. So many of the students, they will make mistake here. Okay, next one, acid amide. If suppose acid amide they have given, acid amide also, this carbonyl carbon you have to consider. Next, acid halide. Now these are the some carbon containing functional group. Then which functional group will not act as a, which functional group will not, are that one we should not consider it in the parent carbon chain. That first one, if OH, this OH functional group will not be act as a which one, parent carbon chain. This is just which one, this is just only the functional group. Many of the students, they may get the difficulty in identifying the ketone. This ketone functional group will not act as a parent carbon chain. This ketone functional group will not act as a parent carbon chain, but it may act, but it is not present in the least or terminal, right? It is present in middle. So this for ketone also you will get somewhat difficulty. Clear? And the NH2, this will also will not act as a, or this will also, this carbon also will not act as a which one, parent carbon chain, or we should not give the least number, or depending upon the groups attached we have to give the numbering according to that one. Then now here we'll start the naming for the compounds. If suppose they have given in this manner, then how to start the naming? Now what I said, carbon containing functional group, if it is present in terminal positions, then this carbonyl functional group containing carbon is a I-period, right? This is 1, this is 2, this is 3, this is 4. Then write the IUPAC formula. 2 degree prefix, 1 degree prefix, plus root word, plus 1 degree suffix, plus 2 degree suffix. Clear? Is there any substituents in this compound? No. 2 degree prefix will say about substituent. Are you seeing any ring? No. Root word, how many carbons we are having? 1, 2, 3, 4. 4 carbon, it will be the bute. 4 carbons, it will be the bute. Any double bond you are seeing? No. In the parent carbon chain, are you seeing any double bond? No. So all are which one? All are straight chain. All are single bonds, right? So this is N. Okay? N. But N. Listen. Next. This is done. This is done. And next one is a 2 degree suffix, right? 2 degree suffix. Which one? This is carboxylic acid. So 1 oic acid. Then already I explained you very clearly in the last class. If any 2 degree suffix or 2 degree suffix, if it is having any vowel in IUPAC name, the vowel which is coming first will be removed, right? Then in this 2 degree suffix we are having which one? Oic acid. Oic acid, O is the vowel, right? So the first vowel should be removed. So we should not represent the E in the which one? E in the IUPAC name. So this name of this one is the bute 1-oic acid. Bute 1-oic acid. Butane 1-oic acid. Clear? This is a IUPAC name. This is very, very important. Whenever, if the functional group, if it is having any vowel, then in the 1 degree suffix, whatever the vowel it is coming, that we should be removed. It should be removed. Clear? This will also will play very, very crucial role. Then next compound. If suppose if they have given in this manner, then numbering will be 1, 2, 3, 4. Name of this compound will be butane 1-all. Here E should be removed because in the 2 degree suffix A is the vowel, right? A is the vowel. So first vowel E is removed. Then next. Clear? Now this is a amide. So name of this compound will be butane 1-amide. Butane 1-amide. Then next. If suppose if they have given this one, then here this is a carbonyl carbon, right? Then you have to give the numbering that one in that manner. This carbonyl carbon should get the least number. If you start the numbering from here, carbonyl carbon is getting 3. Then if you start the numbering from here, carbonyl carbon is getting which one? 2. So naming of this compound will be butane 2-one. Butane 2-one. Butane 2-one is a name of this compound. Clear? Next. If they have given in this manner, then you should not consider this as a parent carbon chain and you should not give the naming from here, because this is not the carbon. In the parent carbon chain only I am saying, I am not saying the parent nitrogen chain. Okay, then this nitrogen you should not consider it as a 1. Then even though this is a functional group, but this is not the carbon, then what the PCC means? Parent carbon chain. Parent carbon chain. Clear? A parent carbon chain. So this one will be the first 1, 2, 3. Name of this compound will be prop 1 amine. Prop 1 amine. Clear? If they have given in this manner. So parent carbon chain I am saying, right? Not parent oxygen chain. So this one will be the 1. This is 2. This is 3. Clear? Now name of this compound will be the prop 1 ol. Prop 1 ol. Clear? Now next. If they have given, better I will take it in the fresh page so that it will be clear for you. This one they have given. Then next here SO3 H they have given. Then here they have taken the O. Clear? Next here here they have taken the 1 chloro. Here they have taken the 1 OH. Here they have taken the 1 what will take? Here we will take the bromo. Okay. Here we will take the which one? Here we'll take some okay, here one double bond, here the H will take. Okay, done. Now this type of the compound they are given and they are asking the IUPAC name. Then what you have to do? Among this group you have to identify the which is the high priority for the functional group. Then this is a carboxylic acid, right? And it is having this carbon. Now this is a high priority and it should be the least number. Numbering will be 1, 2, 3, 4, 5, 6, 7. Done. Now this compound which I was given, now try to write the name of this compound and comment in the comment section. I will cross check the answer of this one. Clear? Done. Next. And another compound also I will give you. Try to write the naming of this compound. This one is, I will give you the numbering 1 for this one and numbering 2. Numbering 2 for this compound. Now here if it is any double bond if they have given, here it is a NO2. Now here it is a Br. Clear? Now here it is a 1 O. Now here it is a 1 H. Now here it is a 1 OH. Clear? Done? Now, if this type of the compound they have given, then what is the IUPAC name for this compound? Now you have to write. Next, third one. If they have given in this manner, this compound they have given, then what is the IUPAC for this carbon or IUPAC name for this compound? They will ask you. Then most of the students they will make mistake here. They will choose a parent carbon chain here, and they will say this as a prop 1 nitrile, because this is a cyanide as a functional group. It will be the prop 1 nitrile or propane 1 nitrile we used to say, but this is wrong. Why this is wrong? Because here this carbon containing functional group, cyanide is also a one carbon, right? So this is also you have to involve in the which one? In the functional group. You have to involve this in the functional group. So this is 1, 2 and 3 and 4. Name of this compound will be what? But 1 nitrile, but 1 nitrile, R butane 1 nitrile, butane 1 nitrile, because here N is not the vowel, so we have to represent the E in the organic compound. Done. Next, then next, if suppose alcohol functional group, if they have given, which one? Alcohol functional group, if they have given, alcohol general formula will be what? Cn H2n plus 1 plus 1 OH. This is a functional group. This is a functional group. 2 degree prefix for the alcohol will be hydroxy. 2 degree suffix for the alcohol will be ol. Alcohol will be ol. Now we'll see the some compound names of this one. Naming of this compound will be, here 1 2. Name of this compound will be ethanol. Clear? Next, if suppose if I ask this compound, now here it is a 1, here it will be the hydrogen, right? Now common name for this one will be the isopropyl alcohol. Clear? Done. Here if you take it as a IUPAC name, then this one will become the propane 2-ol. In this manner also you can write. Suppose if they have given in this manner, naming of this compound will be the common name tertiary alcohol, because this is carbon is attached with the 3 other carbons, right? So this is tertiary alcohol. Clear? Now next comes to the carboxylic acid functional group. If suppose the carboxylic acid functional group, if they have given, now general formula of the carboxylic acid functional group will be Cn H2n plus 1 COOH. Now 2 degree prefix will be the carboxy, and 2 degree suffix will be the oic acid. Done. Now naming of this compound. First one, CH3COOH. Actually common name for this one will be the acetic acid. If you want to write the IUPAC name will be 1 2, right? 1 2. Name of this compound will be the ethanoic acid. You can say it as a ethanoic acid also, or else you can say the ethane 1-oic acid also. Done. Next, if suppose if they have given this one, if they have given this compound, name of this compound will be the formic acid. Done. Now if I want to write the IUPAC name, then it will become the methanoic acid. Clear? Done. Next, some carboxylic group compounds. Common names for the some carboxylic group, that is, this is OH. Which one? This is benzoic acid. Done. Now this one will be the aspirin. Clear? Now this compound is the which one? Salicylic acid. Now these are the some common names of this compound. Now dicarboxylic acid, if they have given, if 2 or more carboxylic acid if it is present, then dicarboxylic acid. If the dicarboxylic acids, if they have given, for the dicarboxylic acid, now the general formula for the dicarboxylic acid will be C double bond O, OH and CH2 N, CH2 N and C double bond O H, C double bond O H. Clear? Now here first N is equal to 0. If the N is equal to 0, then that name of that compound, then compound will be in this manner. The name of this compound will be the oxalic acid. Oxalic acid. Now formula will be C2 H4 O2. C2 H4 O2. Clear? Sorry, C2 H2O4. C2H2O4 is a compound of this formula. Done. Next, if N is equal to 1, now the formula will be, now the compound will be in this manner. Now name of this compound will be the melanoic acid. Name of this compound will be the melanoic acid. Now they can represent in this manner also. Sometimes they can represent the melanoic acid in this manner also. Then if N is equal to 2, name of the compound will be clear. This is carbon. Now here the one CH2, here the one CH2. Name of this compound will be the succinic acid. This is succinic acid. Done. Now if N is equal to 3, if the N is equal to 3, then N is equal to 3 means here C double bond O, OH, here 1, here 1, here 1, here the C double bond O, H, C double bond O, H. Name of this compound will be the glutanoic acid. Glutanoic acid. This is a glutanoic acid. Done. Now if N is equal to 4, then it will be the C double bond O, OH, here 1 carbon, here 2 carbon, here 3 carbon, here 4 carbon. Clear? Here the OH, here the OH. Now this one will be the adipic acid. Now this one will be the adipic acid. N is equal to 5, name will be the pimalic acid. Okay. Now if N is equal to 1, if N is equal to 6 they have given. Now carboxylic acid, 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon, and this will be the carboxylic acid, right? Clear? Now 6 CH2 are we having. Name of this compound will be the subaric acid. Clear? Now this is about the which one? Naming of the dicarboxylic acid. If the dicarboxylic, if it is given, then naming of this compounds. Clear? The next we are going to see the how to write the IUPAC name for the which one to write the IUPAC name for the ester. Clear? If the esters they have given, many of the students they will make the mistakes. Now we see about the ester functional group. If suppose the ester functional group they have given, ester functional group with the R, C double bond O, O, R dash. Clear? Now in this ester functional group, this one will be substituent. Now 2 degree prefix for this one, 2 degree suffix for this compound will be the, what is the 2 degree suffix for this compound? O8. 2 degree suffix for this compound will be the O8, right? Now what is the O8? How to write the naming for this compound? Now we'll see. If suppose here the CH3 they have given. Whenever the ester functional group, if they have given, whatever the alkali chain it is attached here, that you have to write the first. That you have to write first. Clear? Now how to write this one? Alkyl, alkyl, alkanoate, alkyl, alkanoate means whatever the functional, whatever the alkyl group it is attached to the O, that will be written first. So methyl, methyl, then after followed by the IUPAC, then after followed by the IUPAC 1, 2, 3, 4. Then write the IUPAC. 2 degree prefix? No. Any 1 degree suffix, 1 degree prefix? No. Then comes to the root word. What is the root word? But. Root word is a but. All are the which one? Straight chain, or all are the single or single bond. Then it will be the but N, because this is O8, right? O8 is a which one? Oval. So we have to remove the E. Then 1O8. Methyl butane 1O8. Methyl butane 1O8 is a compound name. Clear? Next, if suppose they have given the compound name or compound in this manner. Suppose the compound they have given in this manner. Then here it is a Cl they have taken. Cl they have taken. Then how to write the naming? First, what I said, in the ester functional group, oxygen attached alkali group should be given as a first priority, then followed by the IUPAC. Then this is ethyl. Then this is the ethyl. Then followed by the IUPAC. Followed by the IUPAC means 2 degree prefix plus 1 degree prefix plus root word plus 1 degree suffix plus 2 degree suffix. Now ethyl 2 degree suffix, which one it is there? Chlorine. Then the numbering will be 1, 2, 3, 4. Then ethyl 3 chloro, ethyl 3 chloro. Then cyclic ring? No. Then but, clear? Then which position in is there? 3 position, right? 3 in O8. 3 in O8. Now this is a IUPAC name of this compound. IUPAC name of this compound. Clear? Now this is very, very important. Next, suppose if they have given this compound in this manner. If suppose they have given the compound in this manner, then we have to write the first naming of this compound, right? Naming of this compound. Naming of this compound will be the ethynyl, because this is a ethene. From this ethene, one nitrogen is removed, then it will become ethynyl. Ethynyl, what? 1, 2, 3, 4, 5. So ethynyl 4 bromo, 3 chloro, 3 chloro. How many carbons we are having? Pent, and which position double bond we are having? 4 position in O8. In O8. Clear? Now this is the name of this compound. Name of this compound. Let's suppose if they have given in this manner. Okay. Now this type of the compound they have given. Now first we have to write the IUPAC name for this one, right? We have to write the IUPAC name for this one. What is the IUPAC name for this one? Now this is 1, 2, 3. 1, 2, 3. See, this is a complex substituent, right? Complex substituent should be written in the bracket. Already I explained you. This is 1 methyl, propyl, 1 methyl, propyl. Next, here 1, 2. 1, 2. Now this one will be the which one? Substituent. This one will be the substituent. Which position it is there? 2. Which is substituent? That is 2 cyclo. This is 2 cyclobutyl. 2 cyclobutyl. How many carbons we are having in the parent carbon chain? 2. This is ethanoate. This is a compound name. This is a compound name. Clear? Done? Now, next, fourth. If suppose amide functional group, if they have given amide, then 2 degree suffix for the amide will be amide only. Done? This is R C double bond O, NH2 is a amide, right? Here this is if the here one carbon if it is present, 1 degree amide. If it is one carbon if it is present, 1 degree amide. If 2 carbons if it is attached with the 2 carbons in this manner, NH and here it is NH. If they are given this is a 2 degree amide. Okay. Now if it is attached to the 3 carbons, nitrogen if it is attached with the 3 carbons, then it will be the 3 degree amide. It will be the 3 degree amide. Clear? Whenever you are returning the IUPAC name for the amide functional group, if suppose if they have given the compound in this manner, here the CH3, here in the one CH2, CH3, if suppose they are given. Now here suppose one branching will take, this is a Cl. Then this is the 1, 2, 3, 4, right? Now write the naming. 3 chloro, then after that you write these substituents. After these substituents you have to write this substituent. Then here you have to represent the N-ethyl, N-methyl, butamide or butamide. Clear? Because 1, 2, 3, 4, right? But and this is a amide, butamide. Butanamide, N-butanamide. Clear? Now this is a IUPAC name for this compound. Done? Next, fifth, amine if they have given. If the amine functional group if they have given. If the amine functional group if they have given, this is RNH2. RNH2 means 1 degree amine. If RNHR, this is 2 degree amine. Here R, N, R and R. This is 3 degree amine. This is 3 degree amine. Clear? Now, let's suppose one compound they have given here N, here 1, in this manner they have given. Then how to write the naming of this compound? So here this is nitrogen is attached with the 3 different carbons, right? So for each one you have to represent the N. N-ethyl, this is N-ethyl. Done? Next, this is propyl, right? N-propyl, according to the alphabetical order you have to write. Clear? Now, N-ethyl, N-propyl, cyclopropane, 1 amine. Cyclopropane, 1 amine. Clear? Cyclopropane, 1 amine. This is a which one? Cyclic ring. And this is the functional group, right? Functional group carbon should be given the high priority. Next. Next. Acid anhydride if they have given. If the acid anhydride functional group if they have given. Acid anhydride, if the acid anhydride functional group if they have given, then 2 degree suffix for this one will be the oic anhydride, right? Oic anhydride. This is oic anhydride. Now, how this acid anhydride has been formed? If the 2 carboxylic acids, they have taken, from this 2 carboxylic acid as a H2O will be eliminated. As a H2O when it has been eliminated, now it will form the which one? Acid anhydride. Now this is acid anhydride. Now this is a acid anhydride. Clear? Now naming of this compound will be the CH3, CH2, C double bond O, O, C double bond O, CH3. Clear? If suppose if they have given, then here the E, right? This is ethanoic, and which one? Sorry, this is ethane, right? 1, 2, ethanoic, and 1, 2, 3, propanoic, ethanoic, and the propanoic anhydride. ethanoic and the propanoic anhydride. Done. If suppose if they are given in this manner the compound, both sides same, right? Both sides the alkane chain is same, then it will become the ethanoic anhydride. Ethanoic anhydride. Here 1 2, here 1 2. So both the cases same IUPAC. Then if suppose epoxides they have given, epoxides. Now what is the epoxide? Now this is a epoxide. Done. 2 degree prefix for this epoxide is a epoxy. This one will be the epoxy. Now naming of this compound will be this is 1, this is here, this is 1, this is 2, this is 3, this is 4 and this is 5. Clear? Now naming of this compound will be the epoxy is present in 2 and 3 positions, right? You have to represent in the bracket 2 and 3 epoxy, 2 and 3 epoxy pentane, 2 and 3 epoxy pentane. Now next, if suppose if they are given in this manner, now write the numbering from here 1 2 3 4 5 and 6. Then 2 and 4 position epoxy linkage is connected, right? 2 carbon and the 4 carbon epoxy linkage is connected. So 2 comma 4 epoxy, 2 comma 4 epoxy hexane, 2 comma 4 epoxy hexane. Done. Now if suppose any double bond if it is given, in this manner they have given. Done. Now double bond should be given the high priority, right? Here 1 2, here 3, here 4, here 5 and here 6. Clear? Which position the epoxy group is there? 3 and 4, 3 and 4 epoxy, 3 and 4 epoxy hex 1 in, right? Hex 1 in, hex 1 in. Clear? In this manner now we have to write the names for the which one epoxy or epoxides if they have given. Then common names, if suppose if they have given, then how to write the common names for this? Common names for the which one? Epoxides. Common names for the epoxide, first one, this is a oxyrane, this one is a oxyrane. R 1 comma 2 epoxy ethane, 1 comma 2 epoxy ethane, this is 1 2, right? So 1 comma 2 epoxy ethane. Done. If suppose in this manner they have given, then this is a oxytane, this is a oxytane. Clear? Now this naming of this IUPAC name you just comment in the comment section. Clear? Now here suppose 5 member they have given, this is oxalane. Clear? Next, if suppose 6 member ring they have given, then this is oxane. Clear? Done. Or we can say it as a 1 2 3 4 5 1 2, sorry, this is oxylane is not this one, only 5 member carbon will be there. 1 2 3 4 5. Clear? This is 1 2 3 4 5. So 1 comma 5 epoxy pentane is a naming of this compound. Done. Next, if suppose, next very important, you have to remember that what you have to remember now. Now when carbon containing functional group, directly, when carbon containing functional group directly attached to ring carbon, then ring is PCC. Okay, then the ring is PCC. What is the ring is the PCC? If suppose this is a carboxylic acid, done, then this one will not become the functional group, or this one will not become the high priority. Then the ring will be become the high priority. Which one? Ring carbon. This functional group attached carbon will be the high priority. 1, 2, 3, 4, 5. Then here this one will be, naming of this compound will be the cyclopentane carboxylic acid. Cyclopentane carboxylic acid is the naming of this compound. Done. If suppose if they have given in this manner, if they have given in the naming of this compound will be here 1, 2, 3, 4, 5, right? This one will be the cyclopentane carbaldehyde. This one will be the cyclopentane carbaldehyde. Clear? Next, if suppose if they have given chloride, if they have given this one will become cyclopentane carbonyl chloride. Done. Next, if suppose ester they have given, if suppose ester or R they have given any, then this one will become alkyl cyclopentane carboxylate. Clear? Now if suppose cyanide functional group or nitrile functional group, if it is attached, then this one will be the cyclopentane carbonitrite. Clear? In this manner you have to write. Next, one special rule they have given, one special rule or specific rule of 1993. What is the special rule of the 1993 they have given? This is very, very important. Many of the students, they will make the mistake here itself. No. When 3 or more same carbon, same carbon containing groups, containing functional groups is present in PCC, then we can't able to include their carbons as PCC. So exclude all of them and use special name for them. What is the special name for them? Now we have to see. If suppose if they have given this one CH2 one COOH, sorry, here the one, here the COOH, if they have given, if this type of the compound they have given, then how to write the naming? Because here the 3 functional groups we are having, 3 carbon containing functional groups, so we cannot include this one and this one, so you cannot write the parent carbon chain in this manner, so this one will become wrong. So what we have to do here, how to write the naming? Then this you have to consider it as a which one? 2-degree prefix. Then you should not consider this as a suffix, you have to consider this as a which one? Prefix. Naming of this compound will be the propane 1, 2, 3 tricarboxylic acid. Clear? Tricarboxylic acid is the naming of this compound. Done. Next, If suppose if they have given CH2, CH2, CH, CH2, CN, CN, if suppose CN they have given. Naming of this compound will be the butane 1, 2, 4 tricarbonitrite. Tricarbonitrite. Clear? In this manner, we have writing the IUPAC names for this type of the compounds. Clear? Next, we are going to see the IUPAC names for the aromatic compounds. If the aromatic compounds, if they are given, how to write the IUPAC name? IUPAC name for the aromatic compounds. Okay. Now, some aromatic compounds are considered as a PCC by IUPAC only. So, which are the aromatic compounds that has been considered by the PCC? First compound is a benzene. This is a benzene. Next compound, this compounds, this is CH3 they have given. Now, naming of this compound will be the toluene. Naming of this compound is toluene. And if suppose if they have given this compound, naming of this compound will be the phenol. Then, if suppose they have given this compound, naming of this compound will be the aniline. Clear? Now, if suppose they have given this compound, naming of this compound will be the anisole. Clear? Now, if suppose they have given this compound, naming of this compound will be the benzaldehyde. Benzaldehyde. Clear? If suppose if they have given this compound, naming of this compound will be the benzoic acid. Benzoic acid. Clear? Now, if suppose they have given this compound, naming of this compound will be the benzamide. Naming of this compound will be the benzamide. If suppose the compound they have given, naming of this compound will be the benzyl chloride. Benzyl chloride. If suppose the compound they have given in this manner, if suppose the compound they have given, the naming of this compound will be the alkyl benzoate. Alkyl benzoate. If suppose the compound they have given in this manner, then this one will be the benzonitrite. Benzonitrite. Clear? Next, if suppose if they have given NO2, then this one will be the nitrobenzene. This one will be the nitrobenzene. Clear? Now already I explained benzoic acid. Done? Now this is about the some compounds. Benzene is taken as a parent carbon chain. Then if suppose then when will be benzene will be act as a parent carbon chain, and when will be the benzene will be acting as a substituent? Now you see, for the benzene, for this benzene, if pure alkyl chain is attached. Pure alkyl chain means without any substituents. Without any substituents, only pure alkyl chain is given. If pure alkyl chain is attached to benzene, then benzene act as PCC. Then benzene act as PCC. Name of this compound will be the which one? 1, 2. Sorry, this is 1, 2, 3, 4. Right? 4 means butyl benzene. Butyl benzene. This is a butyl benzene. Clear? Next, if suppose if any substituent if it is present for the alkyl chain, if any substituent if it is present, if pure alkyl chain, if the pure alkyl chain is not present, is not present, then benzene is considered, as which one? Then the benzene is considered as a substituent. 2-degree prefix for the benzene C6H6 is phenyl. It is phenyl. Clear? That is known as a pH. Now naming of this compound will be this is 1 and this is 2. The naming of this compound will be the 1-bromo, naming of this compound 1-bromo, 1-phenyl, ethane. 1-bromo, 1-phenyl, ethane. Clear? Now we'll see some compounds of this one. Then here the NO2, here the fluorine. Clear? Here the ethyl they have given. Then here these 3 will be acting as a which one? Substituents only. Fluorine will not act as a functional group. NO2 will not act as a functional group. Ethyl will not act as a functional group. So here the naming or locant sum rule will play very crucial role here. Then if you start the numbering from here 1, 2, 3, 4. 1, 3, 4 you are getting. Okay. Then if you start the numbering from here, from fluoro 1, 2, 3, 4 we are getting. 1 plus 2 plus 4 we are getting. 1 plus 2 plus 4 is a locant sum rule, right? So the numbering will be start from which one? Fluorine case. Now the numbering will be start from which case? Fluorine case. Now naming of this compound according to the alphabetical order we have to give the naming, right? Then here 4 ethyl, then 4 ethyl. Now 1 fluoro, 4 ethyl, 1 fluoro, 2 nitro, benzene. This is the naming of this compound. Clear? Because these all are the substituents only. There is no any alkyl chain to consider the benzene as a which one? Parent carbon or benzene as a substituent. Then, now here if suppose they have given this compound, which one? Then here the benzene is not the alkyl chain is not the pure. Now the naming will be 1, 2, 3. Now what is the name of this compound? 1-phenyl, propane 2-ol, right? Because alcohol is a functional group. If suppose in this manner they have given here chlorine, then here the 1, 2, 3, 4. Then 1, 4, dichloro, benzene. 1, dichlorobenzene is a compound name. Done. Now if suppose in this manner they have given the compound. Now this compound name is a which one? Styrene. This compound name is a styrene. Next, if suppose the compound they have given in this manner, they have given, then naming of this compound will be the 1-cyclobutyl benzene. Done. Now if suppose they have given the compound in this manner, this is a ketone functional group, right? So this is 1 and this is 2 and this is 3. So this naming of this compound will be the 1, 2, 3. Naming of this compound will be the 2-phenyl, 1, 2, prop, 2-phenyl, prop 2-on or propane 2-on, Clear? Now next, if the bicyclic compounds they have given. Now what is the meaning of the bicyclic compounds? Now if 2 rings are attached, then that compounds we call it as a bicyclo, right? Then now before going to the bicyclo compounds, now bicyclo compounds are, what is the meaning of bicyclo compounds? Bicyclo compounds. What are the bicyclo compounds? Here bicyclo compounds means when two cyclo rings are fused. When the two cyclo rings are fused are known as a bicyclo compounds. Clear? These bicyclo compounds are two types. Then one is fused. What is the meaning of the fused bicyclo compound? Now if you take the one cyclic ring and this cyclic ring is fused in this manner, this is a fused bicyclo compound. Next one is a bridged or else one. Clear? Now this is a bridged carbons. Now bridged bicyclo compound. This is bridged. This is bridged bicyclo compound. Then now this bridged bicyclo compound we can represent in this manner also. This bridged bicyclo compound we can represent in this manner also. How? Here 1, 2, here 1, 2, here 1, here 1, here this is bridged carbon, this is bridged carbon, this is bridged carbon, this is bridged carbon. Now this 1 carbon, 2 carbon, 1 carbon, 2 carbon. Now here 1, in between the bridged carbons 1 carbon is there, right? In between the bridged carbons 1 carbon. Now again this 1 carbon, here 1 carbon. Now again this 1 carbon, again this 1 carbon. Now this same compound again we can represent in this manner also. How? We can represent in this manner also. Now in this manner also we can represent. Now you can see this is bridged carbon, this is bridged carbon. In between bridged carbon 1 carbon we are having. Now here we are 1 carbon, here 1 carbon, here 1 carbon and here 1 carbon. Clear? Now we can, this compound and this compound it is same, and this compound and this compound is also same, and this compound and this compound is also same. All the three are same. Any of the notation they can give. Any of the notation they can give, all the three are same. You should not get confused by giving any of this compound. All the three are same. Then here to write the bicyclo compounds, first of all when the bicyclo compounds if they have given bicyclo compound 1 degree prefix, 1 degree prefix we say it as a bicyclo. 1 degree prefix for the bicyclo compound is bicyclo. Done. Then how to write the IUPAC name for the bicyclo compounds if they have given? First one here, if the functional group if it is also present, that we can give high priority for the functional group also. But before to the functional group, which is a high priority? Ring is high priority. Ring is high priority. This is very, very important. Ring is the high priority in the bicyclo compound. Second point is very, very important. What is the second point? Second point you have to remember that longest carbon path is high priority. Longest carbon path is high priority. Sir, what is the longest carbon path? Means here if you see, if I was taking this one carbon or this one bicyclo compound I was taking. This is a one bicyclo compound I was taking. For this bicyclo compound, better I will take this one so that you will not get any confused. Okay, here 1 carbon, 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 here 1. Clear? Now here the longest ring is the high priority. Now give the numbering, choose any of the bridged carbon. Either you can take the one for this one, either you can take the one for this one. Any of the bridged carbon give the high priority. So this bridged carbon you give the 1. Then after that numbering you have to start it from, or numbering you have to start it from here or here. that it will be depend upon the substituent and it will be depend upon the ring. Clear? Here how to write the naming of this bicyclo compounds? I said you first is the ring is high priority. Next one what I choose, I said longest path of the carbon is high priority. See, if you want to go from this bridged carbon to this bridged carbon, here how many carbons we are having? 1 2 3. 1 2 3. If you want to go it from this bridged carbon to this bridged carbon, how many carbons we are having? 2. Here the longest carbon path is this one, right? 1 2 3. Then if you want to go it from here the only we are having only one carbon. Only one carbon. Means whenever you have chosen the carbon path, first you have to choose which one? Longest carbon path. Longest carbon path means you have to write here it is a large carbon path. Next moderate carbon path. Next one smallest carbon path. Smallest carbon path. These are the carbon paths. Clear? If you remember these 2 points, now you can write the IUPAC name for the any bicyclo compounds. Any bicyclo compounds. Clear? Now first, now we'll write the one IUPAC naming for the bicyclo compound. Now first, if they have given this one. Now what I said, any of the bridged carbon you take it as a numbering 1. Now if I take this as a bridged carbon 1, now this is 2, this is 3, this is 4, 5 and 6, and the last priority will be given to the carbon which is present in between the bridged carbon. So this is 7. This is 7. This bridged carbon is 7. Now what I said to write the naming, first we have to write the 2 degree prefix plus 1 degree prefix plus root word plus 1 degree suffix plus 2 degree suffix, right? Done. 2 degree prefix it is absent because there is no any substituent in this compound. Then 1 degree prefix. 1 degree prefix for this bicyclo compound is bicyclo. After bicyclo, now mention the longest carbon path. Mention the carbon paths in the square bracket. See, if you go it from here to here for this bridged carbon, we are having only 2 carbons. So make it as 2. Then if you go it from here to here also we are having the 2. 2 comma 2. And if you want to go it from this bridged carbon to this bridged carbon, we are having 1. Here we are having 1. To make it as 1. So bicyclo 2 comma 2 comma 1. 2 comma 2 comma 1. Done. Then this is completed. Then comes to the root word. How many carbons we are having? Total 7 carbons we are having, right? Hepto, all are single bonds. So this is heptane. This is heptane. Bicyclo 2 comma 2 comma 1 heptane. Bicyclo 2 comma 2 comma 1. Sorry. This is heptane. Clear? Done. Now this is a IUPAC name for this compound. Next. If suppose if they are given in this manner. Clear? If they are given this one. Now you see this is a bridged carbon. Now this is a bridged carbon. This is a bridged carbon and this is a bridged carbon. What I said, longest carbon path you have to choose. Longest carbon path you have to choose. Now this is, if you take this as a 1, now this is 2, this is 3, this is 4, this is 5, this is 6, this is 7 and this is 8. Done. From this bridged carbon to this bridged carbon, if you are going, you are getting only 2 carbons. If you choose this path from this bridged carbon to this bridged carbon, you are getting how many carbons? 1, 2, 3, 4. Clear? Now in between this bridged carbon there is no any carbon. Then there is no any carbon. Now write the name. Naming will be bicyclo in the square bracket. Now longest carbon path will be the high priority, right? Here longest carbon paths, how many carbons we are having? 4 carbons we are having, so 4. Now next followed by the moderate one. Moderate one, here we are having 2. Now bridged, in between bridged carbon there is no any carbon, so it is 0. Bicyclo 4 comma 2 comma 0. If you want to represent the 0 you can, if not it is also okay. Now 4 comma 2 comma 0, how many carbons we are having total? 8 carbon, right? So all are single bonds, octane. That's it. Bicyclo 4 comma 2 comma 0, octane. Clear? Now, next, if suppose any substituents if they have given for the bridged carbons, if any substituent they have given, then let's suppose this substituent they have given. Now, even though the substituent if they have given, now longest carbon path only you have to follow. Longest carbon path only you have to follow. Clear? Then longest carbon path only you have to follow, and substituent should get the least number. And the substituent should get the least number. Means then you have to select that bridged carbon, which one will give you the least number to the substituent. See, if I select this bridged carbon as the 1 and the longest carbon path is here. So it will be 2, it will be 3, it will be 4, it will be 5, and it will be 6, and it will be the substituent is 7, and it will be 8. Okay. Then if I choose the numbering for this bridged carbon as the 1, then it is 1, here it is 2, here it is 3, here it is 4, 5, 6, 7, and this is 8. Means if I choose the white numbering, substituent is getting 8. If I choose the orange numbering, now substituent is getting 7. So which is the correct one? Which is the correct? Orange numbering is the correct. Then now write the naming. How to write the naming? Same. 2 degree prefix plus 1 degree prefix plus root word plus 1 degree suffix plus 2 degree suffix. Now substituent is present, right? Now which substituent is present? Methyl substituent is present. Now which position that methyl substituent is present? 7th position, right? So write 7 methyl bicyclo. Now mention in the square bracket. From this is the longest carbon path, right? Now how many? 1, 2, 3, 4. So 4 comma. Now here if you go, you are getting 2 comma 0. Clear? 4 comma 2 comma 0, because bridged carbon there is no any bridged carbons between, there is no any carbon. Done. Next naming will be how many carbons we are having total? 8, right? Octane. Total octane. 7 methyl bicyclo 4 comma 2 comma 0 octane. Done. Now next. Suppose if they have given in this manner, and the substituent here it is a Cl. Now what I said, now whatever it may be the substituent or anything it may be present, bridged carbon should be the last priority. Then you can choose the numbering here: 1, 2, 3, 4, 5, 6, and here it is a 7, Then how to write the naming for this one? 7 chloro bicyclo 2 comma, and in between bridged carbon 1 carbon is there, right? So 7 chloro bicyclo 2 comma 1 heptane. Clear? Now this is a IUPAC name for this compound. Done. Next, let's suppose if they have given in this manner. In this manner, if the compound if they have given, then how to write the naming? Now select the bridged carbon. 1, here 2, here 3, here 4, and here it is a 5. Done. Now if you go one carbon, then the naming of this compound will be bicyclo. There is no any substituent, right? Bicyclo 1 comma 1, because here 1 carbon, here 1 carbon, here 1 carbon. So 1 comma 1, pentane. Done. Pentane. Clear? Now this is a naming of this compound. Now next, let's suppose if they have given in this manner. Here the Br. Now here it is a methyl. Now if this type of the compound they have given, how to write the IUPAC name for this one? Here Now you see, select that bridged carbon, which one will give you the lowest sum rule or lowest numbering for the substituent. If I then first bridged carbon, high numbering of the carbon path, followed by the substituent. Then if I choose the numbering for this one, here 1, here 2, here 3, here 4, here 5, here 6, and here it is a 7. Substituents are getting 3 and 7 in the white color path. Done. Then if I go for the which one? If I go for the here bridged carbon, 1, here 2, here 3, here 4, here 5, here 6, and here 7. Now in the yellow color naming of the path, what we are getting? 3 and 6. 3 and 6. 3 and 6 is the locant sum rule, right? So the whatever the numbering we have choose in the white color, it is giving the highest numbering. So the numbering is in the yellow color numbering, it is correct. Then how to write the naming for this compound? Then here bromo and here it is a methyl. Whenever you are representing the 2-degree prefix, root word and 1-degree suffix plus 2-degree suffix. Whenever you are representing the 2-degree prefix, you have to follow the alphabetical order, right? In that alphabetical order, first bromo will come, then after methyl, right? Now bromo is in which position? Third position. 3 bromo, next 6 methyl, 3 bromo, 6 methyl, bicyclo, 3 bromo, 6 methyl, bicyclo, 3 bromo, 6 methyl, bicyclo. How many carbons we are having? Total 7, right? Epto, N. That's it. Clear? Now this is a compound. Sorry. Now 3 bromo, 6 methyl, bicyclo. Now how many carbons we are having? This longest carbon path. How many? 1, 2, 3. 3 comma. Now this longest carbon path. This is a next moderate carbon path. This is 2, right? 3 comma 2 comma 0. Epto, N. Clear? 3 bromo, 6 methyl, bicyclo, 3 comma 2 comma 0, heptane. Done? Now this is a compound name. Done? Now next, if suppose if suppose here the Cl, if this type of the compound they have given, then how to write the naming for this one? See, if you go from this bridged carbon to this bridged carbon, 2 carbons only we are getting. If you go from this bridged carbon to this bridged carbon, we are getting 2 carbons only. Then which bridged carbon or which path we have to select? To select the path for this one, now substituents are also there. Substituent should get the least number, right? Then if you choose the numbering for this carbon, 1, 2, 3, 4, 5, 6, and the bridged carbon is the last priority, that is 7. Done? Clear? Here you can see 1, 2, 3. Substituent is getting 3 and plus 7. 3 and 7. Then if you choose the numbering from here, 1, 2, 3, 4, 5, 6, and 7. Substituent is getting 2 plus 7. Now this one is a correct numbering, right? Then write the IUPAC name for this one. How to write? This is ethyl, right? This is CH2, this is CH3. This is CH2 and CH3. Means normally it is a ethane. CH3. If you remove one hydrogen as a free valency, if you make by removing the one hydrogen and if you make the free valency, now this one we call it as a ethyl, right? This is a ethyl. Done? Now naming of this compound will be here the chloro and here the ethyl. Among the C and E, which one will come first? C will come first, right? Then write the naming. 7 chloro, 2 ethyl, bicyclo, bicyclo 2 comma 2 comma 1. How many carbons we are having? Total ept n. Total 7 carbons we are having. All are the single bonds. So ept n. Done. 7 chloro 2 ethyl bicyclo 2 comma 2 comma 1 heptane. 2 comma 2 comma 1 heptane. Clear? Now next let's suppose if they have given in this manner. Done. Clear? Now this type of the compound they have given. Then how to write the IUPAC name for this compound? How to write the IUPAC name for this compound? Now you select. Here the one bridged carbon we are having. Here the one bridged carbon we are having. Now two bridged carbons we are having, right? In these two bridged carbons, now select that carbon chain or carbon ring which is having the highest carbon path. Here you can see here 1, 2, 3, 4. Here 1, 2, 3, 4. Both the cases it has same. Both the cases it has same. Then after that, then select that bridged carbon. Which one will give you the locant sum rule for the which one substituent? Now if I choose this bridged carbon as a number 1, 1, 2, 3, 4, 5, 6, 7, 8, 9 and it is 10. Clear? Then the substituents are getting 3 plus 5 plus 9. 3 plus 5 plus 9. Then if I go it from this bridged carbon 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now in the white numbering, now substituents are getting 2, 4 and 8. 2, 4, 8 is giving the locant sum rule, right? It is giving the lowest numbering to the substituent. Now this is the correct numbering. Now whatever the numbering we have choose in the red, it is wrong. Then write the naming for this compound. Then how to write the naming for this compound? First you have to write the naming to the alphabetical order to the substituent. According to the alphabetical order, first bromo will come. At which position we are having? 2 bromo, next 3 ethyl, 2 bromo, 3 ethyl and sorry 2 bromo and 8 chloro, next 4 ethyl, bicyclo, now how many carbons we are having? 1, 2, 3, 4. Here also 1, 2, 3, 4. So 4 comma 4 comma 0. How many carbons we are having? 10, right? So this is decane. 2 bromo, 8 chloro, 4 ethyl, bicyclo, 4 comma 4 comma 0 decane. Clear? Now I will give you some compounds. Now try to solve those compound. Clear? Try to solve those compound and answer your answer in the comment section. If any changes it is there, I will answer over there in the comment section. Clear? Now here first simple compounds I will give you. Okay, then or else okay, this is a one compound, first one. Then second one, okay. Now this is a second one and here we are having the one substituent chloro. Then third one, then here it is a bromo substituent. Okay, now fourth one. Now next fourth one, Clear? Now here is a one compound. Done. This is a one compound. Now try to write the IUPAC name for this one. Now last 5 compounds I will give you so that it will be easy for you. Okay. Now try to write the IUPAC names of these 5 compounds. Clear? Now try to answer those answers in the comment section. If any changes are there, I will cross check over there and I will justify your answer whether it is correct or wrong in the comment section. Clear? Next one we are going to see the which one? Spiro compounds. Clear? Now spiro compounds. How to write the IUPAC name for the spiro compounds? Done. Now, IUPAC name for the IUPAC name for spiro compounds. Now what is the meaning of the spiro compounds? What is the meaning of the spiro compounds? Now spiro compounds is nothing but when two cyclorings are attached, when the two cyclorings are attached to one ring carbon is known as spiro or spiro compounds. Clear? For the one ring head carbon or one ring carbon, now the two rings if it is attached, that type of the compounds we call it as a spiro. You take, this is one ring. Okay. Now for this one ring carbon, another ring is attached. Now this type of the compound we call it as a which one? Spiro compound. Done. Next, here in the naming of these spiro compounds, now what you have to follow? First you have to follow that this spiro, this bridged carbon or this interlinked carbon, when these two carbons are what? Attached, when these two ring carbons are attached, this carbon should get the least number. For that, here you have to follow, in the bicyclo compound we have followed from the high path to low path, right? Here in this compound we have to follow low path to high path. Low path to high path. Here we have to follow lowest carbon path to lowest carbon path to highest carbon path. Okay, lowest carbon path to highest carbon path. Clear? Now when you have chosen the lowest carbon path, that what interlinked compound or this attached carbon should get the least number. Clear? Means here you should not start the numbering from the bridged carbon or this interlinked carbon. Here you should not start the numbering from the where this attached carbon. Here you have to start the numbering from that ring which is having the lowest carbon path to give. Here if you commit to here it is having the 2 carbons. If you commit from here also, here it is having the 2 carbons. Anything you can select. So this is 1, 2, now this is 3 and this is 4 and this is 5. This is 5. Now here the 2 degree prefix for this one will be the spiro. This will be the spiro. Now name of this compound will be spiro 2 comma 2 comma 2 comma 2 comma. How many carbons we are having? Total 5, right? Pentane. Done. Now you see. Next, if suppose if they have given in this manner, one compound they have given in this manner, then this is a attached carbons, right? 2 rings has been attached. Then you have to choose the carbon path that it is having the lowest first. If you commit from here to here, it is giving how many carbon paths? If I was started from here to get the attached 2 rings attached carbon, I was getting the here 1, year 2, year 3 and year 4. Then after from year to year, longest carbon path, right? Then it is 5, year 6, year 7 and year 8. Now this is a correct numbering. Correct numbering. Done. Then write the naming of this compound. Spiro, lowest carbon having 3, 3 comma 1, 2, 3, 4, 3 comma 4 comma 0, 3 comma 4 comma 0. How many carbons we are having? Total 8, right? Octane. Total octane. Then if suppose any substituent is present, then how to write the numbering for that carbon? If suppose in this manner, then here it is something one methyl will take, methyl substituent will take it. Here methyl substituent will take, or else ethyl substituent. From where the numbering will be started? Here if you start it from here this is the lowest carbon. Then now if you start it from here, now this is the highest carbon path. Done. Now lowest carbon path to highest carbon path, right? Then after that here the substituent is there. Then substituent should get the least number. Then numbering will be year 1, year 2, year 3, year 4, year 5, year 6, year 7 and here it is a 8. Done. Naming will be here substituent is there, right? At which position where the substituent is there? 1 position. So 1 ethyl, spiro. How many carbons we are having? 2 and here 1, 2, 3, 4 and here it is 5. 2 comma 5. How many carbons we are having total? 8, right? 1 ethyl, spiro, 2 comma 5, octane. Clear? Now the same compound, if another substituent, if it is present, if suppose here something chloro substituent it is there, then how to write the naming for this compound and how to choose the numbering for this compound, now we'll see. Here the numbering will be chosen in that manner. Here this substituent should get the least number 1 and here it is a 2 and here it is a 3. Then here 4, 5, 6, 7. If you go in this manner, this substituent is getting 7. But if you go in this manner, here it is a 4 and here it is a 5, here it is a 6, here it is a 7 and here it is a 8. Because substituent should get the least number, right? Substituent should get the least number. Then how to write the naming for this compound? Naming will be 1 methyl, 5 chloro, 1 methyl, 5 chloro. Sorry. Then you have to go on the basis of alphabetical order, right? Then it will be the 5 chloro, 1 methyl, 5 chloro, 1 methyl, spiro. How many are there? 2 comma 1, 2, 3, 4, 5. 2 comma 5 comma 0. How many carbons total? Octane. This is a compound name. Done. Now let's suppose if any alkene if they have given. No. Here. No. In this manner they have given. Then how to write the naming for this compound? Then start. Here this is a lowest carbon, right? This is lowest carbon path. If you start the numbering from here 1, 2, 3 and it is a 4. Then if you start the numbering from here 5, 6, 7, 8 and 9. Here this alkene, this double bonded carbon is getting 7 and 8, right? Then if you choose the numbering in this manner, let's suppose if you choose the numbering in this manner, here 5, here 6 and here it is 7 and here it is 8 and it is a 9. Here it is getting the 6 and 7 least number. Now this is a correct naming for this compound or correct numbering for this compound. Then how to write the IUPAC name for this compound? Here this is a which one? Double bonded carbon, right? Ene, right? There is no any substituent. Then write spiro. How many carbons we are having? 1, 2, 3. 3 comma, here how many carbon? 1, 2, 3, 4, 5. 3 comma 5. Total how many carbons we are having? Total carbons we are having the known, right? 9 carbons, right? Known and it is a in, right? And which position it is there? In known 6 in, known 6 in. Clear? Spiro 3 comma 5, known 6 in. Done. Now if suppose this type of the compound they have given, then how to write the naming for these compounds? Or if suppose the branchings are present, okay, this type of the compound they have given, then how to write the naming for this compound? Then you have to choose the lowest ring, right? Lowest ring, and substituent in that lowest ring. If the substituent is there, that substituent should get the least number. Here this is 1, this is 2, and this is 3. Here you will get the confused to write the or to choose the numbering. Then you have to choose the numbering in such a way that alkene should get the least number. What? Double bond should get the least number. If you go it from here, here 4, here 5, here 6 and 7, and here it is a 8. Then here it is getting 6 and 7. But if you go it from here, 4, 5 and 6. Here it is getting 5 and 6, and here it is a 7, and here it is a 8. Now this is a correct numbering. Now write the what? IUPAC name. Here it is a bromo, and here it is a ethyl. First will come with a bromo, right? In the alphabetical order. So 7 bromo, and 1 ethyl, 7 bromo, 1 ethyl, spiro. How many carbons we are having? 2 comma 1, 2, 3, 4, 5, right? 2 comma 5, 2 comma 5, total oct. Which carbon at which carbon numbering the double bond has started? 5, right? 5 in. Clear? 2 comma 5, oct 5 in. This is a naming for this compound. Done. Now here we'll see now how to write the numbering or how to write the IUPAC names for our names. Same if our name, my name is Navin, right? Then how to write the IUPAC name for my name? Now let's see. My name is Navin, right? N. This is N. Now here the N, what is the naming of this compound? This is the naming of this compound. Here name of this compound is 1, 2, 3, 4. This is butane. This is a butane. Done. Next. This is a A, right? This is a A. This is A. Now how to write the naming of this compound? Now this is a cyclopropane ring, right? This is cyclopropane ring, and these two are the substituents. Now you see here 1, here 2, here 3. So 1 comma 2 dimethyl, 1 comma 2 dimethyl cyclopropane. Done. Next V, right? Done. V, it is simple propane. Simple propane. Done. Now next, sorry, in the one page it has not came. Then next one is a E. What is the E here? Here 1, 2, 3, 4, 5. Longest carbon chain, right? And 3 is a methyl substituent. Then it is a 3-methyl pentane. And the next one is also E, same. And the last one is a N. So that is a butane. This is a butane. In the chemistry, how I can give my IUPAC name for my own name? Now in the first one is a butane. Now we have seen here, right? One is butane, 1 comma 2 dimethyl cyclopropane, and propane, and 3-methyl pentane, and butane. Now in the same way you also try your name with the IUPAC name. Now what is the IUPAC name of your name? That you just comment in the comment section. Just I will cross check over there. Now next we'll see with the another lecture.